Look at this crap behind me. It looks like most of the stuff you see in movies. In this video, you're going to find out if this is real code or fake code. Stand by. This video is about to start.
This is the Savage Scientist Ed right here, and I'm writing code in a police car.
You heard the intro. You know that this is the Savage Scientist. So, this is a free 31-day course, and this is the first part of that 31-day course. I'm offering it free right here on YouTube. So, prepare yourself to learn C++ in 31 days. This is going to be a 31-day, 30-something day journey to learn the C++ programming language. So if you see me looking here, looking there, looking all over the place, I have monitors all over this place. So we about to learn C++ from the beginning to the end. So what I'm saying is that if you don't have no experience with programming, no experience with C++, then this is the video for you to watch. And also this video is going to be supplemented with this. This is what I used to learn C++ in 1998 or 1999. It was a long time ago with this book. It took me 2 years to read it. So I'm going to take all the knowledge I have from that book, the stuff I think is relevant, and we about to put this in this video along with some other things that's not in that book. We're going to talk about data structures, C++ programming, and all kind of other crap. So it's time for us to get this thing started, right? And now, the prereqs for this class. Two things, computer and the internet. And let's assume you have a little bit of space on that computer. And now, the course outline. This is a 31-day mission, and so far we only have 19 topics on here, or 19 days. This is going to expand as you get further into the course. So I would probably say around day 14, you're going to start seeing day 20 to 31 appear down here in this course outline. So let's talk about the things that we're going to address here. So first, we on day 1 right now. Introduction to programming and setting up DevC++ and Visual Studio Code. We're doing that today. So tomorrow, we're going to be doing Hello World. And right now, first C++ program. But here's a spoiler. We're actually going to write Hello World in this video. And we're going to talk about it more in a second video. So after that, we're going to talk about C++ keywords and syntax. We're going to be getting user input on the 4th day. And on the 5th day, we're going to talk about data type, variables, and naming conventions. And on day 6, we're really going to start doing math. We're going to be doing arithmetic operations. So that means we're going to be doing things like adding two variables, int x plus int z. And we're going to compute the sums and all that good stuff. So stay tuned to day 6. We're going to really start getting into what this is all about. And we're going to talk about the Boolean and logical operators. And we're going to recap all this stuff that we learned up to this point on day 8. And when we get into day 9, we're going to start talking about loops and conditional statements. And we're going to get into those dreaded C++ functions. And we're going to get into the even more dreaded C++ pointers and references. We're going to talk about function pointers. Ooh, them son of a bitch. No joke. Function pointers. Ooh, wee. We're going to talk about structs. And then we have 3 days on object-oriented programming. And then we're going to talk about exception handling and debugging. Then we're going to start talking about some data structures and STL. And we're going to recap all of this on day 19. And then we're going to follow with day 20 to 31 with most stuff. And now, more about me. If you don't know who I am, I'm the Savage Scientist Ed. And sometimes I say the governor of the state of Swampland. So what I mean by the governor of the state of Swampland, when you subscribe to this channel, you become a citizen of the state of Swampland, and I'm the governor. So we have that going. So welcome to the state of Swampland from the governor himself with a big salute. Boom. So I have a degree in computer science, and I've been writing code for a long time. And I've been doing researching in cybersecurity, computer forensics, and all that good stuff. And as you stick around my channel, you're going to see more and more of this appear in upcoming videos. So it's going to be a lot of topics in this series, and I'm also going to do more things in computer science. I used to cover Uber a lot on my YouTube channel, but we doing coding and computer science and technology. That's why it says computer science and technology. This is the Savage Scientist, and damn, I can't wait to look back at this video and see how my channel banner changes in about 3 years. So we got that out the way. So now it's time to get started. Well, I would have to say programming is the task of automation. Programming is making a machine, basically a machine, do something on its own. And that is by a trigger, an event, or something. So my first time programming something was programming a VCR. You're going to set this VCR so you don't have to be there for it to record your favorite show. So first you have to set the clock so the VCR would know what time to record your show. So it's automation. You automating the task. So when you go home, your show is recorded because you was at work at 7 o'clock or whatever time the show came on. So let's take a look at how that applies to computers. So let's look at a computer as a multi-purpose machine. That is really what a computer is, multi-purpose machine, right? So a computer is a general purpose machine that could be programmed similar to a VCR to do tasks or to handle things, to take care of stuff that you don't have the time to do or you don't want to do it all the time. So like printing a document. Just imagine you have to keep writing that. So they create programs to print documents and do things like that. So programming is basically automation. And we're talking about simple automation, like doing something that you might have to, so you don't have to be there and witness this automation occurring, like programming a VCR. Or a computer is basically a machine that could do a lot of things. So let's talk about computer languages. I'm about to start this section off with a good joke. I remember asking somebody in the ghetto, if you could name 2 computer languages, I'm gonna give you $20. What'd you say? Oh, why you ask? Oh, I thought I left something at the ATM.
Oh, no, I thought you were police.
Give me $100 now, I tell you.
Oh, I will.
Name 3 computer programming languages.
3 computer programming languages?
Yep.
What you mean?
And then I'll tell you if I'm a police or not.
What you mean by that? The 3 computer, what you mean?
3 computer programming languages.
Like the type?
No, it gotta be real computer languages. Basic is one of them.
I'm lost.
Huh?
Teach me something.
Hey, I got a YouTube channel, Savage Scientist. Savage Scientist. Subscribe to it and check it out. So this nosy person didn't know any computer programming languages, so I didn't answer any of his questions. So let's move on here. So let's talk about what a computer language is. So computer languages are basically the languages that the machine understands. And they are not, so we understand English, French, Spanish, and all that stuff. So what a computer language is a way of writing code for the computer to understand. And those codes follow rules. Each language has its own rule, just like our spoken languages like English, Spanish, and all that stuff. Each of those follows certain rules. And we call those rules syntax. And we're going to get into more of that in another video, but let's just keep this simple for right now. So computer language, so there are a lot of computer languages. But before computer languages were standardized, we had stuff like we're going to start at the bottom of this pyramid. We had the hardware level right here. The hardware then had machine language. Machine language was this complicated instruction-based language that programmers use to access areas of memory for the computer to do certain tasks. And we kind of simplified that by going into assembly language. Assembly language is basically more human understandable, and it translates to a one-to-one correlation with machine language. So things were getting a little more humanized. So then we came up with high-level languages. So those are the languages that we understand. And really, when you look at this this line really don't exist here. I don't know why this graphic all screwed up like that. So high level languages are stuff like C, C++, Pascal, Java, JavaScript, Kotlin, Python, COBOL. They have a lot of computer languages. So each of these languages are independent. They have their own purpose. Like some people, like COBOL, that's a business language. I don't remember what it stands for. You have SQL, that's a database language, and C++, more of a general purpose language. And C++ came from the C language, and the plus plus just mean that you have object-oriented stuff built on top of C. So we're going to get into that later as we progress in this course. So let's move on here. So the C++ language is a compiled language, and what I mean by compiled is when you create your source code, right here, the source code, you're gonna go through this process called compiling. And what compiling means is it's gonna take linked libraries and all this other stuff and smash it all together and create an executable, or it's gonna create a executable file that is gonna be specific to that computer or that machine that you're running. And when you run that executable, it's gonna translate into machine code. So that's why we have this circle. It says machine code, and we have this hello world right here. So this hello world is just the program running. So this is more of what you would see in languages like C++ and C. And down here we have languages like Java, pretend like that say Java, and Python. That say Python, even though it look like it says Ruby. But Ruby, Python, both of them are interpreted languages. So what an interpreted language is, you start here with the source code just the same way that you do in a compiled language. It's gonna take it's gonna go out and find libraries and smash all that stuff up into a sandwich, and we're gonna call that our executable code. But difference is the executable code runs in a virtual machine for that language. So you actually gonna install this virtual machine on your device. So you're gonna have the Java virtual machine installed on your iPhone or whatever phone that is. That look like an old iPhone. So instead of just clicking on that executable, you have to make sure you have the Java interpreter. And that's why sometimes you have a lot of people saying, "Oh, I don't have Java." You have the wrong version of Java. You have all this Java crap, all these Java problems on your computer because you might have written your code in Java 2.1. So this person have Java 1.5 written on installed on a computer. So that means the Java 1.5 stuff is not going to work because you have an old version of the Java interpreter on your computer. Even though you have that same executable, you have to update your interpreter to 2.5, and now you can see all the good 2.5 goodness running on your cell phone. So that's basically what's the difference between a compiled program and an interpreted program. But languages that's compiled are typically much faster because you don't have this interpreter slowing things down, and at the same time you also have direct access, almost like machine code fastness going on. I mean, it's not as fast as machine code, but you don't have this slowing things up. And now we just have a whole bunch of mess on the screen. So let me clear this. So basically what I'm saying is you don't have things slowing down the compiled language like an interpreter. And sometimes this interpreter is written in another language, a high level, a compiled language like C++ or C. And then that part is turned into machine code. So really it's like you're going to start here, go here, and then you're going to jump here to here with an interpreted language. So this is not really a good slide to show this, but what I'm saying is this don't have nothing to do with learning how to program. This is just some basic information you might want to know whenever you start talking and start getting familiar with the concepts of programming, and that is a compiled language is translated directly into an executable that you're going to run on that specific platform, like Windows, Linux. And interpreted language just mean that you're writing for an interpreter. All right, I think I nailed that one through the flow. So now it's time to get C++ installed on your computer. All right, so we're on the desktop of our computer. So if you're following along using a Mac or Linux computer, then you're going to do something similar, do the same things. So what we're going to do first is create a new folder. And we're going to name this folder Programming. And just like that, this is going to be the folder that I will be referring to, and it's going to keep things simple for whenever we start working on projects. And speaking of projects, inside this folder, you're going to create a new folder called Projects, a new subfolder called Projects. So go in here, New Folder, Projects. And we're going to create another subfolder, and we're going to name that one Downloads. Soon whenever I learn how to spell, folks. So we have downloads and projects. That is the folders we're going to be working out of for the rest of this course. So after that, now it's time for us to get C++ installed on our computer. So it's time for us to talk about two methods of getting C++ installed on our computer. That's our language, C++. So like I said, C++ is a compiled language. So to get C++ on our computer for compiling code, we have two methods. So the first method is installing an IDE. IDE. And what IDE is, that's a integrated development environment. So the IDE is going to come with a compiler, and it's going to have a code editor. And hopefully you could read that. So a code editor is a program that you use to actually display the code that you're writing. It could be something as simple as Notepad and have a separate compiler. As long as you save your file as a .cpp, it's going to compile into an executable. But an IDE is a program that combines both of these, compiler and code editor. So we're going to look at one example of a code editor. So if you go to my YouTube channel and search for Visual Studio Code, it's going to present you with these two videos. So if you want to install Visual Studio C++, just follow the steps in this video. And if you have any problems, follow the step in this video, because there is a known error right now that whenever you install in the compiler, you might get this error that says file has been downloaded incorrectly when installing the Min GW64 compiler. I have two videos on that, so I'm not going to discuss it, but if you have any trouble, just follow these two videos. First one is installing Visual Studio Code, and if you have trouble, just go to this video. So what I'm going to do is I'm going to show you an IDE, since I haven't discussed this on my channel. And if in people with Linux and Mac, I'm going to take care of your specific situation too, because I'm going to do a video on installing Visual C++ on Linux and one on installing it on Mac. So now it's time for us to install an easy, no-nonsense way of getting some C++ programs compiled on your computer, so you don't have to worry about installing two separate programs. We're going to do it with one. So I'm going to have a link to this program in the description of this video. So first of all, you're going to go to DevC++ and download it. And you're going to save this download in your folder on your desktop, or if you decide to save it somewhere, just save it somewhere so you can get access to it. So save it on your desktop in the folder called Programming. So now that it's downloaded and it's in place, so let's navigate to the folder. So it's in downloads, right? So there it is right there. So you're going to double click on it. Now we're going to get presented with the installer. So first is load and setup. So once it's done loading setup, let me close this. And I want you to see this. So we're going to select English or whatever language you have. It might be Spanish or something. So we're going to do that. And then next thing going to pop up is this user agreement stuff, the normal stuff. So we're going to click next through all this. And we're going to install it in the default location. Let this install. So now, so this is what it looks like once you install and extract the program. We're going to just hit next through all this crap. And yes, we're going to use all this. Keep everything default and basic. Because we just trying to start writing some code. So this is what it looks like. DevC++. It's a pretty nice, lightweight program. So we can start compiling stuff now. And writing C++. So go up to File. And then we're going to select New. File, New, Project. And this is where your desktop location where we have that project folder is going to come in handy. So we're going to create a console application. Then we're going to go to our desktop. And this is why our desktop is so easy, because you could easily get to it and select that folder. So you're going to select desktop, and here go our folder called programming. Right there, we're going to select that folder. And there it is, downloads. We're going to put it in our projects, not downloads. So select projects. And now we have project 1 in the projects folder. So this is where all these projects that we're going to work on going to be saved. Even if whenever we start using Visual Studio Code, or if we start using another project, another C++ compiler, we're going to put all those projects here. So there it is. So now we have our code. It's almost written. So we want to write hello world to the screen. So come here and just type in std cout. I want you to type in exactly as I'm writing this. And then we're going to put these two greater than signs here and type in the word hello world. So if it automatically put an extra double quotation mark up there, then erase one. You need to have one after the D and one before the H in hello world. And then we're going to put a semicolon at the end. And then we're going to go up to File and Save. And we're going to save this as main. So when we save main, we're going to go back into our project 1 on our desktop. All right, so on our desktop, here it is. Here's the programming folder. So we're going to put it in the programming folder. It's big, so you won't miss it. So now we're going to just save our main program in the projects and then hit save. And this should also make it so next time you go into this program and start using it, you won't have to keep going into all these different folders. We have the folders already saved into the program, so it's gonna make it easy for you next time. So what we're gonna do is name this. We're gonna create this main. So hit save, and there it is. So now we're gonna go up to execute, and then we're gonna do compile. This is the step that creates the program. So we're gonna compile. Hopefully no errors. So let's see, 0 errors, 0 warnings. So that means we could run it. So go back up to execute, and then we're going to do run. We're going to hit the run or hit F10. Either one, we okay. So here it is. Hello world pops up. It popped up on my other screen, but here it is. Hello world right there. So this is the first video in this series, and continue on to the next video where we're going to explore more C++ programming. This is going to be a very basic introduction to how C++ programs are laid out. So most C++ programs will start with a directive statement. And this is indicated by this pink color. And our statements here are going to be these black lines. That is a statement. That is our first directive statement. And following that will be our main function. And the main function also has several statements. And those statements would also include keywords. And in most compilers, our keywords will show up as blue, depending on what compiler you decide to use. And we might also decide to have a function call in our program. And that function call would also have keywords. And sometimes keywords are referred to as reserved words. But our function also has statements and a return type. We might also have a loop in our function. And that loop would also have some keywords. And these keywords could be things like declaration of values like ints, floats, doubles. And of course, it's composed of statements. And we might also drop some comments so other programmers will know what we did here. And that will be a line comment. This would be a comment that starts after this statement. And we could put another one in here. So in our loop, this could also be a break statement. And that's going to return us back into our function that's going to return some value. And back into our main function might be most statements until it finally ends with its own return value, assuming it's not a void statement. So we could also comment out our entire program by using one big comment. The compiler is going to ignore all of this. And now, when we get ready to build our program, we have to assume there is no errors, which is indicated by these red lines. So as a developer, most of the time you're going to be fixing these. And after you think you fixed one, two might pop up. So let's assume we don't have any errors. And let's look back at our simplest program. This would be our main function. And this function will print the word hello world. And we're going to talk about what all these statements mean. And remember, statements are these black lines. The compiler will look at each of these statements for correctness. And if you have a problem, you will get an error. Now it's time for us to talk about our real Hello World program from day one in DevC++. As you can see, this is our Hello World example. And you notice the green, the include statement, that's our directive. And this is our main function. And you can see here, we have a cout statement that prints hello world to the screen. And our main function is going to return 0, and that's the end. This is a very basic program, but we're going to talk a lot more about what all this stuff mean in the next video. But I just wanted to show you a quick hello world program. So now it's time for us to move on to C++ keywords and syntax. What up, folks? This is the Savage Scientist Ed, the governor of the state of Swampland. And you ready to get back into our Hello World example, C++ programming? Alright, but first, let's have a good word from our quiz. You thought it was a sponsorship, huh? Haha, here we go. Question number 1. What is a compiler? Pause the video, answer the question, and now, So a compiler is a piece of software that takes your source code and link it together with libraries and all type of other stuff, and is going to create an executable file, assuming that everything checks out and that you're following the rules of the language. So that executable file will then be specific for the computer that you're writing this code on. So you can't take this executable and run it on a Macintosh because it haven't been compiled for Macintosh. So that kind of goes into question number 2. Is C++ compiled or interpreted? This should be an easy question for you to answer. So just pause the video and answer this question. So if you don't know the answer, then it is a compiled language. C++ is compiled. And the last question, what does IDE stands for? But even I forget this one. So IDE, you ready for the answer? Need some hold music? All right, here goes some hold music for you. I can't afford hold music, so I'm gonna have to make my own hold music right now. All right, so IDE stands for Integrated Development Environment. See, I'm about to screw it up now. I'm about to say Individual Debugging Environment, but no, it stands for Integrated Development Environment. So let's see where we're at in our course. So on day 1, we were introduced to programming and setting up DevC++ and VS Code, depending on which compiler you want to use. And then we basically wrote our first Hello World program without any explanation. So on day 2, I gave you an abstract view of what a C++ program would look like. A generic abstract view. That's all it was. So we then talked a little bit more about a few of the statements in that Hello World example. So today, we're about to go a little further. We're going to start talking about C++ keywords. We're going to talk about the syntax of the language. And it's time for you to start getting familiar with your compiler if you're not already familiar with it. So that's our agenda for today. All right, so let's talk about understanding your C++ compiler. That's very important. And what I'm talking about is, in order to go through this video and understand your journey to becoming a C++ developer, master savage developer, then you got to be able to know, you have to know your way around your C++ compiler. So we're going to be using DevC++ and Visual Studio Code throughout this series. So now let's take a look at some keywords. Here are a very comprehensive list of probably 90 C++ keywords, probably 85, 80 something C++ keywords. And this list is current as of 2011 C++ standard. So there's a 2017 standard, and I think they're working on a 2020 something standard. So we're going to cover a lot of these keywords, but some of them won't, like ASM for assembly. We won't be covering this one. And there's some other ones, like probably won't talk about mutable too much, and probably not volatile. But we're going to see what we're going to talk about here. So let's see. So and also I want you to notice that we are on part 2, keywords in C++ syntax. That's this section we own. So now let's start our C++ compiler, because we're going to get into syntax and all that stuff. Just hold on a little while. First we have to get our DevC++ on the screen, and here's mine. And we're going to open that Hello World example that we created in the last video. So you go to File, and if you click right down here under the print setup, it's going to be a list of your previously opened projects. Like in this example, I only opened one project, so this is that project. And you could also select Open and then select that same project right here. So I'm just going to do it like that. So if you notice, the text is a little bigger from last time, and this is highlighted blue now. And I'm going to show you how I did that. So what I did was I went to Tools, Editor Options, and under Fonts, this is how you change the size of the text. So let's go and make it 8, size 8 text. So if I roll the rest of this series like this, you probably won't finish the rest. You probably won't even get through this video. You're going to be like, this is a fool. Look how small that text is. And you're going to unsubscribe and do all that other stuff. So let me change it back. And subscribe to my channel so you don't miss no more of this series and some more good stuff. So let's return that text back to the size we need. Go to fonts and then change it to 17. 17 worked for me. 20, 21 might work for you. Whatever, 19 or 12 might work. I think 12 is a good size, but since I'm doing this video and this is gonna appear on YouTube and you might watch this on the cell phone, I gotta get a decent size so you could see what's going on here. So another thing I want to do is see how I have this stuff highlighted. This is actually about to transition back into the keywords. Let's take a look at those keywords again. So here's the list of keywords. Can you tell me some of the keywords? Identify those keywords. Do you see any? Give it a little time. Put some holding music on if you need some more holding music. Here we go. 1, 2, 3 keywords. That's int, character. CHAR, that's character. And we have another keyword, return. So we have, look like 4 keywords being used. And let's go to colors and change the colors of these keywords so you could do more things. I mean, you might want those keywords to be a different color. So we're going to go to editor options and colors. And now just select the keywords. You see how I have this here and they say reserve words. So that's another thing. Keyword, reserve word, whatever some people call it keyword, some people call it reserve word. Whatever it is, it's all the same. These are words that you can't use to identify variables. These words are like commands to the compiler that's used to create your executable. So you can't name something int or float, but you can say int underscore I or something like that, but you just can't leave the word int alone. It's gonna turn colors, and if you just saying, hey, let's say I'm gonna just name this thing int. Now you probably could name it with a capital I, but you just can't name it with a lowercase I. And that also goes into the C++ rule of case sensitivity. Capital NAME is not the same thing as capital N, capital A, capital M, capital E. So you can't do that. They got a lot of things you can't do. So let's go back to this. So that's our keyword int or reserve word, like they have it right here. And we could change the color. We could make this color lime green. And now it's lime green. I don't like how that looks, so I like how the blue looks. So you could go in and change those colors the way you want to. I'm gonna just leave it blue, and I'm gonna make it so my string literals are fuchsia colored. Let's see if I can find a string literal in here. They had one earlier. I messed with this thing earlier. There's our string literal. So that's already fuchsia colored. So let's go back and change this back blue. That's it. So now we have that going. And we're going to talk about comments next. This is a block style comment. So everything in between the 2 asterisks, asterisk here, the compiler will ignore that and treat it like a comment. A comment is just like leaving a message for the developer who is going to use this code. Anybody who see this code is going to look at this and notice this is comment. It's almost like writing notes to yourself or writing notes to people who come back and read your comment. So this is a block style comment, and this is a linear comment or a single line comment, or this is going to start, the comment actually start right here at this special symbol, and it ends at the end of the line. So I could start commenting here, just typing stuff here, and the compiler will not process this. So I could even declare variables in here. Equals 988, and the compiler will not even see this. So I could actually show you a little more of this. Watch this. I just commented out this whole line. So this is one big comment with another comment in it. Now, how is that? So I could actually force this on another line, and that is just a comment on its own line. So all this will be ignored by the compiler whenever we compile this. So let's take a look at it. So to compile your code, you're going to save it first, because whenever you compile code, it's going to look at the last time you saved. So all the stuff that we just did, if it's not saved, it won't be computed in the compilation. So do save, hit save, and now we're going to go to execute F9, that's for compile. And right now we have 0 errors. And when you compile, this window is your compilation results. Right here on the bottom, you see where it says errors 0 and all this stuff. This is the results of the compilation. And this is our code, and let's run it. So to run your code, you're going to go up to execute again, and then you're going to select F10 for run. And if you do it like this, you're going to get this pop-up box, and you see nothing is printed. No hello world, nothing. And just hit enter key to continue. So that's it. So let's uncomment this line. And we could also uncomment this. Well, this is already a comment. So now let's put this back on the line how it was. So this is how it was. So now we have to save this again. Go up to File, Save, and now execute, compile, and we have 0 errors, 0 warnings. And now go back to execute, to the execute command, and now F10 for run. And now let's take a look at what we have. There it is, hello world. And I'm about to show you how I like to run my code. So if you come down to the bottom where there's a tab that says console, select that tab, and then you're going to select this CMD. Now we have our own console running right here within DevC++. That's a trick for us developers. So let's take a look. You can run your commands like dir to list your directory. And if we want to run our program again, this is what you're going to do. Just type the name of the program, and our program is the executable. All this other stuff is not important. Those are files that's made during the compilation. So just type in project 1 or the name of the executable, project, and there it is. So do not type the exe behind it. Let's see what's going to happen. That's what happens whenever you type project.exe. It's not going to work because it's automatically going to look at executables and run it. So you don't have to type the exe behind it. So to clear the screen, type CLS. And now we back at our path, showing you where our files are located. Like I said, it's on the desktop programming folder, projects folder, and project 1. That's where we located. And that's a simple way to get straight to our work here. So now it's time to talk about more C++ syntax, right? So code is stored in logical blocks processed from right to left and top to bottom. So let me tell you what I mean by that. So when you start here on this include statement, it's going to first start right here at the leftmost position. And then it's going to go across, scan across here from left to right. Just like we read from left to right. And then it's going to start going down. It's going to go to this space. This is what we call white space with nothing in it. And then it's going to skip this comment. It's going to go to white space again, skip this comment, white space, and then it's going to start compiling our main function. So that's this part. So once it gets to the end, it's going to compile. Hopefully you don't have any errors. So let's talk about errors. So what an error would look like if I was to say something like this. Let's just uncomment this line. And now let's do a save. Do Control S for save. And so go up to compile, F9 on the execute menu, and there it is. We have errors. We're Houston, we have a problem. So it doesn't recognize what all this junk mean because it's scanned right here. This is out of scope, and it didn't even get a chance to even declare this value because this error prevented any of this stuff from happening. So the compiler just stopped right here, and it didn't return anything. So it won't get to this line because this error just prevented it from executing anymore. This prevented it from compiling anymore. One error would stop the compiler. So the easiest way to get rid of this, to stop this error, is to just get rid of the problem. So I'm about to just either comment this out or just delete that line. And now let's go in, do Control S again, save, and now go back up to execute, compile with the F9 key. Now we have any problems, and now we could run it right here in the console. So just push up until you get to it. So remember what happened when we typed project exe? That's not going to work. Project 1. Here it is. We got hello world again. And that's it. And whenever you compile your code, let's hit F9 again to compile. It automatically switches back to the compile window. And now we could just go back to console and just run our code again. So now let's go back and take a look at some more C++ syntax. We're at the semicolon part now. Every statement ends with a semicolon. And this is a semicolon after this statement. So a statement is a line that's processed by the compiler. So we have two statements. This is a statement. This is a statement. And this main function could be looked at as a statement. And we could actually put a semicolon at the end right here. To, just to keep it consistent with our semicolon. So if you notice, I haven't said anything about this include IOStream yet. So that could be considered a statement, but it's not a processing statement like this. This is a preprocessor directive. That this is just saying to the compiler that we're going to use IOStream. We're going to use some components of the IOStream library or class of functions within that library or part of it. So right here we're using the scope resolution operator that's telling us that we're going to use the standard template library, and we're going to use the cout function within IOStream std. So we're going to talk more about that later in the video, but this is just telling us that we are printing out to the screen. This line is just saying print hello world to the screen. See that? So that's IOStream. So another thing we could do is we could get rid of this std part by putting in this line using namespace std colon. So what this is saying, and we have two more. We just introduced two new keywords too, using and namespace. We're gonna talk about those later. So this is not really important at this moment to learning how this hello world example works. But if you just type this in, just put this in your code, and that makes it so you don't have to type in std : to make cout work. That's all that's doing. So this is the main function. This is the function that the operating system is going to look for to execute your code. So this is the beginning or the entry point into your program. So once the program finds main, that means it's going to allocate space in the operating system, memory, and all that good stuff for this thing to run. So it's going to create memory for hello world, any other variables we're going to create, but that's a little advanced for right now. So basically main is necessary to get your program in Windows or Linux, Unix, whatever you use in Mac OS. We're going to have a main function that just tell the operating system that this is where you're starting from. This is the starting point. So this is an int function. This is just telling us that our function is going to return a value of int. I mean, this 0 is an integer value. So that's why it's saying return. I mean, this function is going to start with a return value, and at the end it's going to return a return value. So that's it for our C++ main function. So we print the word hello world, and I'm gonna have a video on getting user input where we're gonna talk more about cout and this include IO stream part. So if you were using Visual Studio Code, this will look a little different, like I said. Yeah. So one thing I like about using Visual Studio Code is that we have this thing called code complete. So when I type in std scope resolution operator, see how you get this list of different functions associated with that? That's called code complete. There are many different names for it, like IntelliSense and IntelliType. There's all type of names for it, but basically this is what it's talking about. This is kind of like completing the text. So if I were to type in ABS, there it is. Now it's a function called absolute value. And another thing, when I typed in ABS, see how it's telling you all the different versions of absolute value? We're going to talk more about this because this has to do with functions. So that's code complete. We're going to switch and start using Visual Studio Code eventually, but this is an easy to use compiler. So long as you have this on your computer for right now, we good to go. So that's code complete. So now we done explained or got a better idea of how to use our compiler, how to use our command line, and this is it. So this is comments. We have two types of comments that we could use in C++, block style and line comments, linear comments. So another thing here, in our main function, we have all this. This stands for argument count, argument vector. At this point, we're not using this, so you could just get rid of it. So, and what that is saying is, whenever we run our program, you could run it with stuff like this. And what this is doing is, you see this LKL, LJ, what all this crap is right here? This is the contents of ARGV, ARGC. ARGC is just how many we have. We're gonna talk about that more later, but this is just parameters that we're going to use to run our program. That's not necessary right now. So you don't need it. Let's run our program without it. So let's see here. So first we're going to save. And now we're going to go up to execute and compile. Our program just compiled just like this. So we just took all that crap out of our main function. And now let's go to console and just run our program. And you run your program by typing the name of the program. And if you don't remember the name of your program, just type dir, and there it is, project 1. And there it is, hello world. Hello world just ran, and here is our main function. And that's it. So I have a challenge for you. Modify your hello world statement to display something unique. It could be a statement or a phrase. So what I'm saying here is that to just change up your code. Be unique. Be very unique. And let me know if you have any problems with this. And don't forget to subscribe to my channel. Okay, so we just got done knocking out our topic of C++ keyword syntax in the compiler. So now, day 4, getting user input. We about to work with streams and all type of other things, and we're gonna print words to the screen. So stay tuned for that. Video number 4 is Ed, and we about to get back into our C++ in 31 days. And note, it might show 15, 16 topics, but we're gonna cover those. We're gonna have more than that. So let's get into the next part of this course. So we have a challenge here that I left you with. I was asking you, how did you modify your program? What did you do to it last time? So how did you modify Hello World? Did you get it to print some type of unique statement? Tell me about that experience. And jump ahead to 4 minutes into this video if you want a more detailed explanation of this solution. Let's look at where we are here in the course. So we already covered C++. We already got our introduction to C++, setting up DevC++ and VS Code. We already got that installed. We passed that. So we talked a little bit about our first C++ program. That was the Hello World that you just got done modifying. And while talking about our first C++ program, I went into a brief introduction to some C++ keywords and C++ syntax. So now we're on user input.
Quick FYI, we did mention compiler also.
So here's the index for this video. And jump to the topic that you are most interested in, or just continue watching it from this point on till you get to the end. So now it's time to start getting user input. So now it's time for us to start talking about IOStream. And if you don't remember, let's get our code back on the screen from last time so you could see what this IOStream is all about. So here it is. We have DevC++ back in action. And we're about to open our previous program. And here it is. Hello world. Just the way we left it. And let me bring this down one line. So here it is, our hello world program. So we left off talking about the return function and all that stuff. So we're gonna look in details at, we are about to dive a little deeper into IOStream. IOStream is a part of the C++ programming language. It's part of the STL, stands for Standard Template Library. So this is a big deal here. So we're gonna look specifically at two functions in IOStream. We're gonna look at cin and cout. So cin is basically what you use, and it's right here. Cin is what you use to receive, let me do some receiving hands, to receive data from the user. Cout is when we pushing it to your screen. So when you see that box pop up, boom, there it is. That is cout in action. And these format specifiers, these overloaded operators, these are basically shift operators. We're going to get into shift operators and all that stuff later, but we're going to just use it in the simplest form, using these. So let's take a look a little more at our program. So here it is. This is our program. So you could do a lot with this thing. So let's go up and just put a little code in here. So let's see here. So as I told you, you could change what you say here. You could change that from hello world to goodbye world. Yep. So what we printing right here in between these double quotes, that's gonna be printed to the screen. So this line prints to the screen. And we already discussed comments. This is a comment. So what about printing to a new line? So what if I do this? On a new, we got stuff on a new line, right? So before you move on, guess what you think this line is gonna do. What do you think is gonna happen? Goodbye world, stuff on a new line. And once you're ready to move on, or once you unpause the video, let's move on. So push F11, don't hit control. Push F11 on your keyboard. And compile it. So another thing you could do in this compiler is you could float this window. So if you right click on the window while it's in dock mode, and you go to floating, these two options down here, floating project manager will make it so this thing floats. And if you select, let's go back, floating report window, now your results from compilations and all that stuff is gonna float. That's just a little side note. So here's the results of our program. Let's go back and run it again. Project 1. So as you can see, we got stuff on a new line that's actually printed on the same right next to the D in hello world. We start with the S. You see that right here. So let me show you what actually happened. This cout statement, even though it's on a new line, it is printing the stuff or it's printing the next string of characters right after the termination of the last string. So when this string ended at the D, it immediately started printing this. So this is the same thing as doing this, cutting it and putting it right here. That is essentially the same thing. So let's run an F11 and see that it's not any different. So now let's run our program again. See, same thing. So let's fix this now. So we want this on a new line, right? So what we're gonna do is put the backslash in right here between the D and S. So there it is. So let's see what's gonna happen with our modified code. Push F11, and now let's run our code again. Right here in the console. And now we have goodbye world, stuff on a new line, on a different line. That's what we wanted. So now it's time to talk about this. This is an escape character in IOStream, or when you're using IOStream in the C++ language. This has a special purpose. So the only way, so the thing is now, how do you print a backslash? So let's take a look at a list of some of these things. So that's the new line one that we just talked about, and here goes some more. And here's the backslash right here. If you want to print a backslash, just backslash, then you're just gonna type 2 backslashes for 1. That's it. So same thing with the question mark, the print the quotations and all that stuff. And here's a good one. Let's do the audible bell. Try and make this thing a little more interesting for people here. So let's get our code back on the screen. So we're gonna just change this to new line, and then we're gonna put an audible bell at the end. So let's save it. Control S. F11. So did you hear it that time? It made that Windows chime sound. So let's run our program multiple times in the console so you could really hear this. See what we got here. You heard it? So there it is. So we were able to make it so it made a little noise. And normally, that's kind of a sign of some error or something. But in this case, we made the noise on purpose by using the alert. So that's our alert. So there's a carriage return. And what a carriage return is just like hitting return on the keyboard. So can you tell me what this line is going to print? Ready for it? Let's compile it. Hit Control S to save first. And now F11. And now let's take a look at our results right here in the console window. Let's hit Project 1. And there it is. We have all this crap on the same line, even though the results showing it on 2 lines. So ENDL, this line right here, forces the results of the next cout statement to its own line. So it's the same thing as doing that. I mean, that is what it's gonna look like. If you take this off, it's gonna print on the same line. If you remove ENDL. So I hope that was helpful for you. So now let's take a look at getting user input. So let's change. So for one thing, in order to get user input, you gotta ask a question, right? So let's ask the user a question. What do you think we should ask our user? See how I'm changing up the statements here? How many cell phones do you own? Okay, so now we want the results, right? So now I'm gonna print, oh, okay, you own, oh, what? How are we gonna get the input? How are we gonna get how many cell phones this person owns? Let's do that right now. You own, so we haven't gotten to variables yet, but just take my word that we're gonna talk about it. So if you wanna capture an integer value from the customer or from the user, we're gonna have to find something to hold it in, and we're gonna create an integer value, and we're gonna call it count. See that? We just created a holder for our phones, an integer value called count. Holds integer value of cell phones. So now we have to put in a new statement. So now we're about to get user input. So we're going to type in CIN, and we're going to use the greater than signs. I mean, it depends on if it's greater than, because if it's this side, it's greater than, but if you're on this side, it's less than. So we not in the math video yet, so we're gonna just go with that. So now we're gonna type in the integer value that we want to take the user input and drop it in this value called count. So that's it. So let's say we would have created count, we would have had another integer called water and another int called cones. Then we could use count, cones, or water, because all of this is int. So we can just go with count, and that's what's going to hold our integer value. So count goes right here, an integer value. So let's see what's going to happen. So Control S for save. Control S. And now let's compile it with F11. 0 errors. That's what we're talking about here. 0 warnings. Now let's go to the console tab, and we're about to run this thing again. Just push arrow up, and it's gonna run the last command. How many cell phones you own? Let's say I own 98 cell phones. Oh, okay, you own. So what? Where is my data? Now, how do you print our 98 cell phones? You wanted to say, oh, okay, you own X or count cell phones. So to do that, we're going to use our cout statement. We're going to use our cout function again, because this is actually a function. And we're going to use cout one more time. And this time, instead of putting something in quotation marks, we can just drop the value that we want here. And we're going to put count right here. So see that? Count. So now let's run this again. Control S to save. And now F11 to compile. Now we got our results about to pop up on this screen when you hit the console tab. Hit up. And there it is. So how many cell phones do you own? Let's see. I own 66 cell phones. And here it is. Oh, okay. You own 66. So isn't that looking a little better? So what about, let's just say you own 66. 66 what? You own 66 cones. Or whatever else I had. What I had up here? Water. 66 waters. So we're going to print now more text. 66 phones. And now you want to force it on a new line. You could drop a new line right here. Now we got a new line to go with it. So now we're gonna hit Control S to save. And now we're about to hit F11 to compile. And we're gonna open up the console tab right here. There it is. How many cell phones you own? 76 cell phones. So now we have it. 76. And look how look at this. 76. The 6 is right after the So we're going to go straight from 76 to phones. So if you want to have a space after your 6 and 76, or if you want a space right after how many phones you have, you're going to put that space right here. And now we have a space before we start the word phones. So it's just like having a space after and a space before how many phones we have. So that's how this CN statement just received input from the user in the form of how many cell phones the person has. So now it's time to print that right here using the variable count that holds the count of cell phones. And we're going to drop that, pow, put it right there in the middle of this statement. And that's it. That is all we're talking about. So I guess you made it to the end of this video. And here's the challenge. I want you to recreate this using what we just learned. You should be able to successfully create a program. And what it's going to do is take in some value that you're going to call your bank balance and print your bank balance that you indicated into the screen, or just print your bank balance. I mean, I know that's not how banks work, but we're going to fix that later when we get into control statements. So we're going to talk about in the next video how to create these variables. What is int? We're going to talk about other data types. And I suggest you go back into my YouTube channel. Check out Data Structures 1, where I talk about data types and stuff like that. Be prepared for it. Data types and variable naming conventions. And that's going to be our next video. So that's your challenge for today. So now, till I make my next video, check out these bloopers. Oh shit, just found the keyboard. Alright, so in this blooper, you got a chance to see where that red line come from. And also you probably noticed that my terrible spelling made it through the editing process. So you probably see that I spelled integer wrong. Cause that's what dictionary's for, right? So stay tuned for the next video. In the last video, we discussed user input, and that's why all this other stuff is grayed out, because we covered it already. And today's video is on data types, variables, and naming conventions of these data types. So, what is a data type? A data type is the most primitive data structure, or the most primitive way we represent data in programming. So, a data type could be used in a situation like this. Let's say I have this cup in my hand. There are attributes about this cup that makes it so we could represent it in a programming language. This cup actually has dimensions, 3D dimensions. It has a height, depth, your X, Y, Z axis. And there's also an aspect that's called, is this cup full, or does it have items in it? So that could be represented also in programming. So let's take a look at these data types. We have three categories of our primary data types. So starting off with primary, we have our counting numbers such as int, and here's an example of an int, 31 or negative 43,298. Those are int values. So we also have float values, and if you notice, the float values has this decimal component. But float numbers can also be these large integer values. So we also have characters. Characters are alphanumeric values that cannot be compared. You can't take a character 7 and add it to 3. So characters are just symbols, such as this open parentheses or the letter A. And instead of the $, we could replace it with the number 4. And this 6 is another character. And our next primitive data type is Boolean, that just represent true, false, two states. So now it's time to talk about these three: short, double, and long. And they are actually modified types for these three, for our primary types. So you won't have to worry about Boolean when it comes to short, double, and long. There's no long Boolean type. So basically what this does is it modifies the capacity of the primitive data types. So let's take a look at int, for example. Traditionally, int is 4 bytes. So let's put that here. So if we were to go to short int, that'd be 2 bytes. So now it is 8 bytes for double. And that's where the name double comes from. So we have 16 here for long. One more quick fact. When we're looking at long, the size could actually change depending on your compiler. It could also be 8. So depending on your compiler, then that's going to determine the size of long. So we're gonna leave it there, and we're gonna talk about the size of operators soon. That's how we could determine the size of all these data types. So now it's time for us to talk about signed and unsigned. And what that basically means is that we're going to treat all the values as either positive or a combination where half is positive and half is negative. So now let's talk about the derived data types. An array is a way of combining many of the same data types within a singular structure in order. So when we look at the word hello world, it could be looked at as an array of characters. Same data type. You can't take and put counting numbers into our array of characters. So this is just it. So you can't put Boolean values in this array of characters here. So when we get into arrays, that's where we're going to start talking more about pointers and references. So this is going to be covered in a later video, but for simplicity, we will be covering arrays pretty soon. So structs, unions, and classes. These three has a lot to do with combining some of our primitive data types into a unique data type. It's like our cup. The cup example is a real good one. So our cup would have values of int to represent the size. That'll be size. And right here would be, is it empty? And then we'll normally write cup up here. So we're going to talk about object-oriented programming, and this is going to make a lot of sense too. So structs and unions, both of those go back to the C programming languages, and classes were added whenever it became C++. So now it's time for us to talk about data types and variables. So a variable is a particular instance of a data type whenever we use that data type. So sometimes whenever we get into functions, we're going to talk more about voids. So you can skip that one for right now, but void just means no data type at all. So null is whenever we create a data type, but we haven't assigned a value to it. So whenever we assign in values, that's when we're doing these two. So a declaration statement is whenever we declare our value, something like this, int x. So we just declared a value of int and we named it x. So to give it a value, we're going to use the assignment statement, which is really just using the assignment operator. So we will do something like this, equals 2, x equal 2. And we could also do this on a separate line or reassign it using it in the operator form. So we would say x equals 7. And yes, you know, in C++ we end our statements with the semicolon. So there it is. So that's the assignment operator and declaration statement. So now it's time for us to move on to some real coding examples so we can see this in action. This is what I called a null value because there isn't any value associated with count. But right here, we're using count without it having a value. So let's see what's going to happen. Remember, save, then push F11. So now it is showing 0 phones. So even though we didn't use it, that is kind of like the type safety that we have in the newer versions of C++, but Before then, you would have got some garbage. So now it's time for us to take this same value and create it as a double. So this is our double count. And we're going to just put a value here. .98. So this is what a typical double would look like. And when we get into arithmetic operations, so whenever we're doing arithmetic, you're going to see a lot more of this type of thing. So that's our count double equals 9.98. So what's even better is being able to do something like this. Bool is high. So this is just something that's saying you either high or you're not. You either going left or you're going right. So we are making a decision on two things. So now we'll just change this to which way are you going? And now we're gonna change this to is high. So I guess we're looking at high or low. So let's say, so what will we set this to? We're gonna assign a value to is high. So what values could we put in is high? And if you said something like high and low, that wouldn't be correct because it's either true or false. So we could do something that's saying true is represented by high. So is high is true. So that means the other. So if you're not high, that means that you got to be low. So that's the way you look at a Boolean value. So is high. If it's true, that means it is high. So if I was to say, so let's just run it right quick. Control S and F11. So it printed a 1. So 1 means true, false means 0. So let's say false here. Let's see what's going to happen when you print whenever we do it as false. Control S. And now let's hit F11. And now we have a 0 here. So that means false. So it's 1 or 0, true or false. So let's see what else data types we could play with here. So we're going to look at a character right quick. So I just want you to know that. So character count So let's see what's going to happen whenever we print count here. You're about to really confuse somebody, but let's see what's going to happen. Compile. So duplicate names used right here. So we have a conflicting declaration. So that's what happens whenever you use the same name twice here. And the only way to get rid of something like that happen is using namespaces. So we're going to talk about namespaces in the future, but so we would say something like C count. See that C count. And now we could go and type and put our C count here. So what you think is gonna look like here? We have C count here. Let me put which way are you going equals so you could actually see what it's gonna look like here. So let's save and now run it. So this is C count, the S, and there it is. C count in our results, C count in our code, right there. So that's a basic introduction to variables. We're going to be declaring variables, and we're going to be doing this a lot in the future. So I declared some doubles down here, and we could look at those two also. Let's just move those up here. So this is how you remove the comments. You just remove those 2 backslashes. So what you think this code is gonna do? This part of the code. Exactly. It's gonna print out this. So this is one of those doubles. So what do you think the value of this is? And that's coming in our math video, but here it is. A double with a exponent of 3. So that is the same thing as saying so that's just like 32 times 10 to the third power. 10 to the third power is 1,000. So that is just like saying 32 times 100. So let's see what this value is going to look like. So Control S to save and F11 to compile. Now let's bring our results over, and there it is, 32,000. Coding standards. So this is just something that you're going to see more in this course. I'm going to probably go with camel case. So camel case is whenever you start with a lowercase letter, and for each new word we would just put a capital letter in. So if I was to say the word doghouse, the word doghouse would be written like this: D-O capital H-O-U-S-E. So kebab case just mean that doghouse would be written like this, with a hyphen in the middle, house. And snake case has been getting a lot more popular. I mean, yeah, that doesn't mean Python with the snake, but that just means that we're gonna write dog underscore house. And depending on what company you decide to work for, they're gonna have their own take on this style coding standards. And now look at our code again. And I mean, there's not really a lot going on here. Now we just formalized the process of declaring variables. So can you tell me what's a declarative statement? What's an assignment statement in here? So if you pick this one, this is a declarative statement. And this is an assignment statement. This is a statement that does it all. It's declaring a value and assigning it a value. In our last video, I told you to modify our cell phones program that asked you how many cell phones you own, and it printed out a count of how many cell phones you own. So this is what that modification should look like. Now, you're at liberty to change this code and create your own variables, your own names, just like I did. So instead of using bank balance, you can just use balance and stuff like that. So let's do a quick walkthrough. So starting on this line, this is our main program, and this main program is this entire section, and this is our outside declaration statement. All this stuff is required to get the program running on our computer using C++. So this statement is where we declared our bank balance as an int, and right here we printed words to the screen that says enter bank balance. So on line 12, I'm asking you to enter your bank balance, and this is what it looked like in the console. On line 13, we asked the user to enter a value, and that value was stored into our bank balance. And right here, we printed the bank balance is, and we took the information from the bank balance and we dropped it into the line that says your balance is whatever you entered. And this is where the program left and returned control back to the operating system. So this is what that looks like. This is line 12. Let's enter a value. We on line 13 now. So you have 766. So this is line 13 being active. And this correlates to line 14, where it says your bank balance is 766. This 766 is this part right here that says bank balance. And We put an inline here, and that's why you see an extra space after the 766. So that's the solution to our program. We just got done talking about data types and variables and our naming conventions. Now we're about to talk about math and order of operations. So we on day 6, math and arithmetic operations. We're going to discuss quite a few things in this video. So now it's time for us to take a look at the order of operations here as it relates to C++ and math. And you might notice, look how it says day 5 plus 1. That's because I had to redo this video for you. So you can't start talking about order of operations without going through PEMDAS, which is a common acronym used to define the order of operations. Parentheses, exponent, multiplication, divide, and that's not a percent sign, divide, add, and subtract. And in C++, we have parentheses, multiplication. I'm having extreme trouble trying to draw stars. Divide, modulus. So to add a little confusion your way, in C++, the percent sign does not mean percent, it means modulus. So just keep that in mind going forward. Addition, subtraction, and equals. And priority goes down. So just like in math, in C++, we're going to take care of whatever we have in parentheses first. And then we're going to work our way down all the way till we get to the equals. So if you notice, there's no exponent operator in C++. So we can't compute to the third power, which is 8. We're going to learn later how to do this using functions and loops. So let's take a look at a quick expression here. So let's say 2 times 3 plus 7. So we're going to just put some parentheses in here so we can make it clear on what we're going to compute first. So we're going to do our 2 times 3, which is 6, plus 7. And if we do 3 plus 7 times 2, that's going to give us a different answer. So order of operations is good, so we won't have problems with computing these values out of order. So it's time for us to do the math. To pick back up where we left off. And don't forget to hit the subscribe button while you hear me ramble on. And now let's start DevC++. So we could start practicing with a simple calculator app. This calculator app is just going to take 2 numbers and add them together. And guess what? I found my glasses. You don't want to play with somebody looking like this. So open up that damn DevC++ and let's start working. So go to File and open up our last program, and you're going to see all this junk again. We're going to just erase all this and start fresh. Start from scratch. Here we go. So now I'm about to declare 2 variables, int x and y. And this is how I declare 2 variables on the same line. This is the same thing as saying int x and y. I have 2 ways of declaring y. You could either do it like this, or you can put them all on the same line. So either way, both of these are suffice. So now we're gonna take 2 numbers and add them together. So let's assign them the values of 98 and 76. So we just assigned values to these numbers. So now let's do a sum. So this is how you print the numbers to the screen. We're gonna just say the result. So we're gonna do a cout, C-O-U-T, cout, and put our parentheses there. The result of x and y is, and we could throw an equal sign, and we want a space between the values that we're about to return here. So we could return x plus y just like that and do a inline. We could do our inline statement by just typing in ENDL and drop the semicolon at the end, and that's it. So now we're going to return 0 to exit the main function. Return 0, semicolon. Control S, that's going to save, and now F11 to compile and run. So did you notice any errors? Because I didn't. So the answer to this one is 174. So this is a very basic program. It doesn't do anything, but I just want you to see right here. We returned in the IOStream function, in the IOStream cout function, we were able to add two numbers. So what if we want to save the results of that? So we would say int result. And now we are storing the sum of these two numbers. We could replace that x plus y with result now, because we just put x plus y right here. So now we could put result. And do you want to see what's going to happen if you add a float and an int value? Float 98.1. So what you think is going to happen when you try to do this? What? Put in the comments. 50% chance that it won't work. 100% chance it won't work. Will it work? Let's see what's going to happen when we add 98.1 to 76. So here's the answer. We still got 174. But do you notice something? Where's the decimal part? We just have 174. So let's go into detail on why we still getting the 174 and we don't have our decimal part. Let's see what happened if we do 98.9. Will our results be different? So let's save, and now let's run it. So the answer is still the same. So whenever you add a float and a int, it's going to ignore the decimal part of it. And so if we had, and another thing, you can't do this. You can't just create a int value and put a decimal component to it. Let's see what's going to happen. So after saving, compiling, and running our program, the result is still 174 because we are still using an integer value to hold our result. Now let's change this to a float and run it again. And now you can see we have the decimal part of the result. So notice, we still don't have the correct sum. 76.6 and 98.9 does not add up to 174.9. So the reason why we're not getting the correct answer is because we still have an integer value representing our y's. We're going to have to change that to either float, double, or some type of precision-based number. So let's do that now. We can do double. And now let's see what's going to happen. So now we have the correct value. That'll be bad practicing to declare int and put a decimal component in it. So don't do it. Even if the compiler lets you do it, don't do it. And another thing, if you're not using a double component, just declare it as float like this. And one quick note, floats and doubles are both the same thing. It's just double takes up 2 times more space than float. So now it's time for us to add more functionality to our basic calculator by working with user input. Here we go. Enter. We're gonna give it a title here. So we're gonna call this Poor Man's Calculator. That's the title here. And on the new line, we're gonna practice using the new line symbol. We're gonna type first number, enter first number. And we're gonna get the user to put in the new number. So we're going to inline here. And we are about to ask the user for a number. CIN. We're going to get user input and we're going to replace so we're going to take the user's input and we're going to put it in the variable X. And we're going to do the same thing again and get Y. So let's see, we're going to take this line and just copy it. And make sure you put it after this line because we just got the first value, so now we're working on the second value. So we're going to see out again, COUT, and now parentheses, enter second number. And I don't like how this compiler actually starts filling in things. So here it is. So now we're going to inline, ENDL to inline, and now CIN for, now we're about to CIN for the Y value. And now we're about to we're going to drop some more lines of code right here because we want the results. So we're going to just copy that line. Yeah, I do a lot of copying and pasting and just, let's see here, and just put the same crap here. Saves a lot of time. The result equals the result of X, and Y. So there we go. We're going to just put results right there. And another thing, we're going to move this line. We're going to copy this line, just cut it out. And we're going to paste it after we get our last user input. So we're going to move, we just move results down here. So now let's Control S for save and run it with F11. So here we go. Enter your first number. We're going to say 898. And now enter the second number. We're going to do negative 1000. And here it is. The result of X and Y is negative 102. So let's see what happens if we move our results back up here. Control S for save. And now I'm about to F11 and compile this again. Let's see what happens. So we're going to use easy numbers here. 1000. The second number, we're going to say 400. So we should have 1400, right? See how we still got the 175.5? This bug comes from the fact that we created our result on line 13. And then we got user input on line 15 and 17, but we didn't update it before we printed our new results on line 19. And another thing, we're using floats. So you notice how I didn't even put a decimal component in the last part? So I could have did this with ints, but we're using floats. So floats almost have the same abilities of int, but it's just that these floats take up a little more space. So as your program become more demanding, then you might decide to want to use ints where it's appropriate. If we're not going to be using these big numbers, then we don't need to use doubles and longs and all that stuff. Float will do it. But if you're not using the decimal component, then you don't even have to use floats. You could use ints. You could use even shorts. So let's change this to short. And now we could just come up here and roll with we don't even have to, we're gonna just, yeah, let's do this. There we go, 8 and 7. So we're using shorts. Shorts are even smaller value. They're integer values, but they take up less space than int. That's it. So let's Control S for save. And now let's run it with F11. Here's our calculator. So enter a number. So we're going to just put 444. And there it is, 15. So let's see what's going to happen whenever we move this down here. And the thing is, you notice how it still computed it with the float value. So right now our results, we want our results to be in its proper form, short We're not going to be doing this with doubles and all that. We won't be mixing. From this point on, you will not see me mixing and add numbers unless we do what we call cast. That is the proper way of converting something like converting an int to a double, or we converting a character to an integer value or something like that. That is called casting. I'm gonna have a video on that in the future, but from now on, if we're gonna just use the data type that we need to. So we're using shorts right now, so we're gonna continue using shorts. The short is just a short integer value, half the size, 2 bytes. I'm thinking it's 2 bytes, but check my last video to make sure I'm correct. So now let's compile this, and we're about to put some numbers in here. So first number is going to be 44, and the second number is 24, and there we have it. It's adding and doing what it needs to do. So now, so later on we're going to talk a little bit more about making it so this thing could change operations. So we want to be able to divide. You want to be able to multiply, subtract, divide, and do all that other stuff. So right now the only way we could do that is if you want to divide, then you could just change that to do this. So that's it. But we're gonna just play with these, but I want to show you something a little different here. So let's say we have, let's get rid of this. So we're gonna play with the different operators. So let's do some things here. So let's see. So we have x divided by y. 8 divided by, we're gonna change this to 81 divided by 7. So let's see what's gonna happen when we run this. So there's our answer. Notice that this is not the answer that you want, because what about the remainder and all that stuff? Let's see how to get the remainder now. This is how you get the remainder. So that's it. So let's combine these two because we want to show remainder and so let's see. So we'll just name this short result remainder, and we're gonna do another short result. And now we're gonna have to print two things here. Remember in high school, elementary school, whenever you took arithmetic, you had that little part where you did remainder. So that's our remainder right here. So now and look at the naming convention. I'm using the same case here. And this is camel case, but notice that start off with the small r. You just can't rename this with a capital R. You're gonna run into trouble. We won't compile. So that's it right there. So now let's Control S, run this again, and take a look at our answer. So there it is. 11 remainder 4. And you might notice something else. There's a space, and soon as it printed the results, it printed the number right on the side of the R. So you put a space right here, and that's gonna make it so it's kind of like the result is right here. This is our result. So we wanted a space in between our results. So even though I put a space here, that don't mean that it's gonna be a space there. So with the computer, well, what's printing to the screen is everything inside these parentheses. So if I put a space in between the R, then that means we're gonna have a space before and after results. See, this is the space before, and this is the space after. And that's why it's printing the way it did. So now that's it. So let's use different numbers. So we're gonna use 971 divided by 7, and what's the remainder? We're gonna change that to 76. We want a big remainder. So now, Control S save, and now F11 to run this thing. Here we go. Here go a nice one here. We have a big number here. So we have the divisor of 12 with a remainder of 59. So that's what I'm talking about. So the modulus operator is how we get in the remainder. This is called modulus. And just notice we had to create two shorts, one to hold the results and one to hold the remainder. So now it's time for us to multiply some numbers. I don't like this keyboard. You might see me using a different keyboard next time. I just like how nice and clicky it sounds, but that's for another day. So let's change this to multiply. There we go. So let's uncomment this line right here, because this is where we declare our results remainder. And we could take this line out, and let's get rid of the use of results remainder right here. And now we shouldn't have any trouble compiling this thing. Let's see, I got rid of that, and there it is. So here's our answer, 8260. 971 times 76 is this big number, and the remainder part is still printing. We don't need this either. And there it is, results. And so that's it for right now. We just played with a little bit of arithmetic, and we just built a very basic calculator. So we're going to get into Boolean operators next. We're making our way slowly and surely towards the big picture here. So we just got done talking about math and all this stuff here, math and order of operations. So for our next video, we are about to start talking about Boolean logic and programming. This is whenever we about to really start making things make a lot more sense, because we were just doing these little basic programs, adding two numbers. So we about to start getting into loops and stuff like that. So all this stuff is building upon each other like you've seen here. So Boolean logic and programming is next. That's where we're going to introduce more operators. So this is the Savage Scientist Ed right here. And you already know that I'm the governor of the great state of Swampland. And until I make my next video, peace out. On this 7th day, we're going to cover Boolean logic as it relates to programming. And I'm going to introduce the if statement. So stand by, because this video is about to start.
This is the Savage Scientist Ed right here, and I'm writing code in a police car.
What's up, folks? You already know who this is. This is the Savage Scientist Ed. Now it's time for us to take a look at our Boolean operators, or logical operators, whatever name you want to call them. I interchange them both. So let's take a look at the priority. We're going to rank these from high priority to low priority, starting with the negation operator, and then we move to our comparison operators. We have our greater than, and we have our greater than equals. That's exactly how it's written here, greater than and equals. In the math class, you might see a combined sign with a line on the bottom, but we're looking at the C++ way it's done. So since there's no line with a line up under it, like in math, we got to write it like this. So same thing for our less than, equals. And then we're looking at our equivalency operators. That is the two equal signs. That means that we're going to be comparing the left to the right. If they are the same value, then we're going to say that's true. And if it's not, we're going to say that's false. And now it's time for us to flip the script and look at the not equals. And for our not equals expression to be true, that means that the actual expression has to be false. So 5 is not equal to 7. That's actually true because they're not equal. So that's why it became true. And in our not situation, if you set the two values equal, then the result is going to be false. So last, we're going to take a look at our logical comparative operators. This is our logical and, meaning that we're going to have a condition on the left side and a condition on the right side. And the left and the right side has to be true for the entire expression to be true. And we're going to look at our logical OR operator. What that means is that we could have an expression on the left side, or we could have the expression on the right side. Only one of those has to be true for the expression to be true. Both of them could be true, but you can't have both of them false. If both of them false, then the entire expression is false. So normally in a logic class, you'll see this stuff in the truth table. But to keep this video short and simple, we're going to just move on to the code. So this is what our little ugly ass program is about to look like. We about to create the poor man's calculator here. And it's going to have additional functionality based on what operation you're going to choose. So we're going to implement logic so you could be able to enter two numbers and decide whether you want to add, subtract, multiply, or divide those numbers. So let's start creating this shit. So we start in DevC++. Let me get it in place here. All right, so now let's open up our last program, our last project, and here it is. And we're going to start off by getting rid of all of the assignment values, and we're going to change our x and y to ints. So like I said here, we're going to be saying we're going to do our arithmetic operations on the values x and y. So we're going to continue to use the same name, poor man's calculator. And let me space that correctly. Let's get that in the right spot. So I'm also going to force this onto its own line. So that's in this part. And put an ENDL statement right here. And we're going to get rid of this new line because we put this on its own line. Like this. So we have poor man's calculator, and now we're going to say enter the first number, and this is where, and right here we're going to actually get the first number. So now we're going to ask for the second number, and we're going to get the second number with this line. So we're going to also create a value called result. Well, we're going to use our results. Let's move this up to our declaration section where we declaring our values, our variables. So we're gonna have another int called results, and we're gonna name this one remainder with a lowercase r, and I'm gonna move that up to the top. And I'm gonna get rid of the mathematical part here where we calculating the remainder. And I'm going to get rid of all this stuff up here too. This isn't necessary. And now we have cleaner code. We have our x, y, remainder, and result. And what else we're going to need? Program. So let's start here by calculating our values here. So we're going to need one to hold our choice. This is our declaration section, and this is the actual programming logic starting here on line 12. So the first thing we're going to do is ask for the choice. What type of calculation? To perform. All right here. And we're going to just list out our full calculations here. And I'm going to say something like enter 1 for addition. And we're going to continue to repeat this 4 times because we're going to be looking at 4 operations. And let's clean this up. All right, so we're gonna do 2 for subtraction. Three for multiplication. And 4 for division and modulus. So those are going to be our 4. Those are going to be the 4 options you're going to have with this calculator. So now let's get user input CIN statement in here for the choice. So now we're about to look at the if statements part. So if choice has the same value as 1, that means we're about to do our addition. So I'm going to put a comment here just so I can know we're doing addition. And now we're about to put the logic in right here. So what we want to do, we just want to print something out to the screen saying this is the results. COUT, out. And we're going to say the result of, now we're going to say X and we're about to print our plus sign right here, plus. And we actually printing the value of X and Y, not just X and Y. And you can tell that because you see how there's the X's outside the parentheses and the Y outside the parentheses. That's so we know we printing real values here and Y. So, and we're putting the space before and after our values. So the result of X and Y equals, now this is where we're going to compute X plus Y. And there it is. And we're going to end our statement right there. This is all we doing. So when our choice is equal 1, so that means that you entered 1 right here, we're going to have this results. And we're going to copy this whole thing and do the same for the rest of the operations. So let's copy and paste it here. So if choice is 2, we're going to do subtraction, right? And we're going to change this to say subtraction. And the only thing we're doing is changing this to subtraction. And we're going to do a subtraction sign right here in our code so it could compute X minus Y. And now we're about to do the same for the third step of multiplication. Look at that spelling. I could have put an X there, but that star sign seems to work better because that's exactly what we're doing right here. You see, it's star, not X. We're not doing that. We're doing star because we already have an X there anyway. And let's see, we have our choices of 1, 2, and 3 for multiplication. And we have one more to do. If choice is 4. Now we're about to do our division and modulus. And let's add, we have to add one more part to it. We could just say mod of X modulus Y. So there we have it. So now it's time for us to check to make sure this is working. So let's compile it. And there it is. So let's test it out. Let's see what happens if we type in 76 and 3. Let's add them together first. 76 plus 3 is 79. So I want to test everything without having to close the program. So now let's run this in the console. Let's see, project 1. 42 and 354. What we want to do, subtract. So subtraction is 2. There go our big negative number. Let's try this again. This time with 7. We're going to be multiplying. So 7 times 10. Multiplication, number 3 is 70. And now let's do this one more time for dividing. So we're going to say 876 divided by 65. Hit our number 4 here. So there it is. 876 divided by 65 is 13 with a remainder of 31. So there we go. So now it's time for us to play with this, and let's break this program. So let's run it again. Enter our first number. There's our second number. So let's enter 9. And when you enter 9, you see how we not getting anything. So what I'm about to do now is restrict the program to make it so no matter what value you type, it's gonna give you an operation. So when we hit 9, we're gonna look at the remainder of 9, and it's gonna give us probably let's see. The modulus of 9 and 4 would be 1, because 4 because 9 divides 4 2 times, so that's 8, and 8 will give us a modulus of 1. Let's make sure. Let's use our calculator. It's a calculator, right? So let's see what the modulus of 8 and 9 is. I mean 4 and 9. So let's run our program again. So let's type in the first number is 9, second number 4, and we about to run number 4. There it is. So that's it. 9 divided by 4 is 2 with a remainder of 1. So there it is. Damn calculator really coming in handy right now, right? You made a calculator. Be proud of yourself. So now it's time for us to restrict the values. So let's go back to our choice right here. And we're going to set choice to modulus. Choice equals choice modulus 4. And that's going to restrict the values to only 1, 2, 3, and 4. But really we're going to have 1, 2, 3, 0, and 4. So when it's 0, we have to deal with it, because watch what's going to happen whenever we run this thing with 0. Let's rerun our program. Open it up down here in the console. So our first number is 84. We're not really worried about that. So what's going to happen when it's 0? So let's type in 64, because like we know, 64 divides 64 8 times with 0 as a remainder. See, we got that again. We are about to make it so when we hit 64, it's going to give us the fourth choice and give us the remainder, division, and modulus. D-I-V-I-S-I. I spelled it right. All right. I want to make sure here. So the only thing we're going to do is use our logical OR sign. Check it out. We're using OR. So we're saying choice is either 4 or choice is 0. And we're computing our choices to be restricted to only those values. So really right here, we're saying choice is going to be 1, 2, 3, 4, or 0. So really, we don't even need this part. But let's look at it anyway. Since it's here, we're going to leave it here. So let's run our code again. We're going to put it right here so you can see. Enter the first number, 432. And let's type in 4. There it is. So let's run it in our console this time so we can keep it on the screen. I'm going to try 423, 21, and we are about to use 64. And there it is. So let's look at what's the remainder of 64. 64 and 4. And 4. There it is. See that? When it's 0, there it is. That's our mod right there. So now let's look at what would happen if we take this 4 off right here. So if our choice is 0. So what's going to happen when it's 4? Let's see. But if you listen to what I just said, then you already know what's going to happen. So let's see here. So let's take 448. You know, I should have just did the numbers that we're working on. So let's do 4. Put our 4 in here. See, there it is. And that's the same thing as we don't even need choice is 4 because 4 modulus 4 is 0 anyway. 4 divided by 4 divides 4 one time with a remainder of 0. So that's it. So we're going to work on some more of this. We're going to make it so this program, which doesn't even have a return value. So let's put our return value here to make it so it's a complete program. So y'all should have caught that. So now our program is complete with a return value. So next time when you join us in this C++ journey, this C++ mission, we're about to talk about what is next. Okay, so we just got done talking about the topic of day 7, Boolean and logic for programming. We're about to recap everything on day 8 tomorrow. And then that's whenever we're gonna, on day 9, we're gonna continue with our loops. So we got a lot more stuff to cover. We got all this stuff to cover. So this is the Savage Scientist Ed, Governor of the State of Swamplands, and you just watched our 7th day of programming. So till I make my next video, we're going to do this on the big screen. So till I make my next video, peace out. What's up, folks? This is the Savage Scientist Ed. We're about to look back at our 7 days of programming. And before you move to day 9, make sure you understand the stuff in this video. So we're about to recap this in 2 minutes.
Oh, hold on. Let's do 3 minutes.
So to start, C++ is a compiled language. And code written in a compiled language will be translated into an executable file. And that executable file is specific for the computer that we are using. For example, your Windows executable will not run on a Mac. Now, to create our program, we use an IDE. That's an integrated development environment. That's a piece of software that contains 2 components, an editor and a compiler. And we write our code in the editor and we create our executables with the compiler. And now, of course, we use DevC++ as our IDE. And it can be easily found by searching Google or clicking on this video. So once you install DevC++, we're going to start off with a new project. And you do that by clicking on the new project and following these examples. And then we're about to start writing some code. So this interesting line of code is what we use to gather user input and print things to the screen. Next, we move into our main function. This is the main entry point into our program. The function body starts with an opening curly brace and ends with a closing curly brace. With the power of the IOStream library, we could now print Hello World to the screen. And if you don't like Hello World, you could always change it to say whatever you want it to say. And if you don't follow the rules of C++, you will get a syntax error. And in our example, please remember, C++ statements must end with a semicolon. All functions, including the main function, should have a return value, unless we declare it void. And we'll talk about that later. Keywords and reserved words are words that we can't use to name variables in our programs. And speaking of variables, this is how you declare a variable in C++. And each variable must be within a certain data type. This is the IOStream operator that we use to get user input. The user will type some value and we're going to put that value in a variable X. In C++, we could do all the arithmetic computations like add, multiply, subtract, divide, and get modulus. in C++, there's no power operator, so we can't do this. Boolean operators is the last thing we're going to focus on in this video. Boolean expressions are two-state operations. That means true or false, 1 or 0, all or nothing. We are looking at two things happening here. So in C++, we use the bool keyword to declare a Boolean value. And Boolean values are important for making decisions. So you might start seeing things like the if statement. The if statement will take a value and look at if it's true or false, and we're going to go with that decision. You may be noticing right here I'm saying subscribed equals true. What I'm doing is assigning a value true to the variable subscribed. And inside our if statement, you see two equal signs. That is very confusing, I know. So what I'm saying here is if the value associated with subscribed is true, then that means we are going to print the word thanks to our console window. So let's say we said subscribe equals false. That means when we get into our if statement, we will not see the word thanks printed with our output. The program execution will skip the portion of code within the curly braces. So the difference between the single equals symbol is that means we are assigning a value to our variable, and the double equals means we are checking to see if this expression is true or false. So that's basically it. You can always go back to the video that cover these specific topics and brush up on any of this stuff that isn't familiar. But for everyone else, it's time for us to move to day 9 and continue learning C++. In this video, we about to talk about some loop statements, and I'm testing out this Insta360 webcam. Stand by. This video is about to start.
This is the Savage Scientist Ed right here, and I'm writing code in a police car.
What up, folks? This is the Savage Scientist Ed, and you already know who this is because you watched the intro. So, this video is sponsored by my subscribers, not Insta360 or the company behind it. And now that we got that out the way, let's turn the lights up and see what happened. This is high-powered light mode. And most likely, this is how I'm going to get the sharpest image. But you know this, the Savage, so I like to keep things dark here in the state of Swampland. And this is what I'm going to be looking like most of the time I use this camera. In this little small circle, the bottom of your screen, not bothering you while you code because you need as much screen real estate while you're doing some coding, right? So here go the topics for this video. Jump to whatever you want to get to or whatever you want to watch. You know I don't want to waste your time, keep repeating this crap. So you already know the ordeal here. Jump to whatever you want to see. And now it's time for us to start talking about these loops. So we're going to start off with the if loop. And we're going to talk about the while. And then we're going to talk about our for loop. And last, the switch statement. Here is one way to increase your chance of getting that $100,000 a year FANG job. Do not refer to if, while, and for statements as loops. If you use the terminology control flow statements, just like lawyers have their own terminology, here in the programming world, we have our own terminology too. So it's time to start using it. So for the rest of this video, I'll refer to loops as control flow statement. And we're going to start by declaring a variable called x here. And this box represents the control flow statement. And this is the condition that holds the control flow statement. And this is the logic that will be processed while the control flow statement is true. And within these curly braces is the body of our control flow statement. And remember, control flow statements are our basic loops. If, while, for, switch, you know, the ones we talked about earlier. And this is some condition. So we could say something like while x is greater than 5. So we're going to start with our if statement. So if x is greater than 5, we're going to process these two lines. And We're going to do that one time, and our program will continue on the outside of this curly bracket, or if our condition x greater than 5 is false. So let's say we get to our if statement. So let's say x equals negative 3. When we get to this line, our program execution is going to jump here, because this is only this. That means that this became false. So that's the beauty of our if statement. So now let's take a look at some more statements here. So let's look at our while statement. So we'll just say while x is greater than 5. So right here we're going to say x is 2. So while x is greater than 2, we're going to have a continuous loop that will not stop unless we have some value in here that manipulates the value of x, something like x plus plus. So with each iteration through this list, or each loop, we're going to repeat it. So the first loop is going to say x is 3. Next time we go through it, x is going to be 4. The next loop, x equals 5. And next loop, x equals 6. Once x is 6, we're going to break out of our loop and continue processing right here. And that's the basics of our while loop. And now it's time for us to take a look at our for loop. Our for loop is almost follow the same logic as our while loop. So let's say x just happened to be 6. In our for loop, the bounding condition will dictate how many times we're going to loop through this code. For example, we're going through this loop 6 times. And with each loop, our value x is going to increase. So once it increases to 7, we're going to exit out of our for loop and continue processing. And that's 6 loops. And that's it. And normally these 2 lines of code could do whatever we want. We could print stuff to the screen. We could change the way our loop behaves by having it increment over 2x instead of just incrementing x by 1. So now it's time for us to take a look at our switch statement. So let's say we're looking at a value x. So this is like selection. So we're going to say if our switch statement basically combines the if statement. So if x equals 3, we're going to process something here. And now, if x is 4, we're going to process these lines of code that corresponds with the statement x equals 4. So the switch statement combines the power of the if statement nested. So normally in our switch statement, we would have a variable, or we're going to have a condition that breaks out of our switch statement. In that case, our program execution will continue on the outside of the bracket. Now it's time for us to start DevC++. And we're going to start a new project. Console window application here. And we're going to name this control flow. Or we could just say CTRL-FLW. And we won't be using command line arguments, so we're going to get rid of that. And we're going to put our using namespace std right here. So that means we're using our standard template. So we're going to declare 2 values, int x and int y. So we're about to redo our if statement. So if you haven't seen the last video on Boolean operations, we're about to cover a little bit of that right now. So let's create a basic program. So we're about to ask the user for a number. Enter a number greater than 5. Now it's time for us to place that number in our variable with the CIN function. That's it. So now it's time for us to use our if statement. If x is greater than 5, we're going to print out cool, you entered, and we're going to print out our value x which is then 5. So let's get ready to run this thing. So in our case here, we're going to enter 6. And that's what we got. See? We entered 6 and that's greater than 5. So what happened here is the user entered 6, and since 6 is greater than 5, we were able to print this line. So let's see what's going to happen if we enter a negative number. What you think is going to happen when you enter negative 12? That's right. We will not get anything printed to our screen. So now, how could we fix this? We want to go back up here if you enter a value that's greater than 5. So let's do this. We're about to use the else statement. Else go to. So we're going to print two things. Cout you entered a value less than 5. And now we're going to say go to start. And now we're going to put start right here. And it is terrible practice to use go-to statements, but this is a demonstration on why it's good to use all these loops. So let's say we entered 3. You enter the value less than 5. So now we're asking for a number again. So we're going to say 4, 5, 56. So now, cool, you enter the value 56, which is greater than 5. Now we can leave our program. So all the other values we just entered did not work, including 5. So 1, 2, so any value less than 5, including 5, will not work. So if we want to include 5, we do it like this. So this is 5 including 5 itself. So if I run this again now, we can enter 5. And there it is. Cool, you entered 5, which is greater than 5, which is greater. This should also read, which is greater than or equals 5. So that's basically how this loop works, how our if statement works. So if we look at go-to statements, we have to pair that with our label. Our label is on line 9. And in C++, the proper way to create a label is to end it with a colon. And if we start adding go-to statements or adding labels, let's say we have a label right here called label 2. label 1 up here. And then we start referencing these labels. So let's say right here we have X going to L2, and we have this, instead of this return, we're going to L1. And as you start adding more references, it starts to really look like spaghetti. And that's why they call it spaghetti code. I don't know how to spell spaghetti, but let me look it up. Spaghetti. And this is bad practice. So don't use go-to statements in your code. So now it's time for us to clean that up a little bit using other control flow statements. So we about to put our while keyword to use and make a while loop. So we about to make a counter. counter, counter. So let's get rid of the bad stuff here. And we're going to get rid of this because else doesn't work with while. So let's just put so this is one of our new loops here. So we're about to reference it. While. So we're going to change this to while. So while X is greater than 0, we are going to count down. And so now we're going to change our writing here. So countdown. From X value. So we're going to name it countdown. And now enter a start for countdown. And that's our CIN statement. And now we're about to just change this to countdown. So can you spot the bounding condition on our while statement? Exactly. That is X being greater than 0. So we know the direction that we're going to start counting down. And we're going to get rid of this 5 right here. And we're printing X. And we want a space in between it. So we're going to just put a space there. That's our space going. And now let's decrement X. X equals X minus 1. We could also have said X minus minus. That does the same thing. So now it's time for us to demonstrate our while loop. Countdown. Enter a value for our countdown. I would like countdown on its own line, so let's post that on a new line there. There we go. There it is. So we're going to start with 85. And there it is. So we just start our countdown, and it's a very fast countdown, instantaneously. Count it down from 85 to 1. And that's it. So how did this work? We just created a loop that started at 85. And it looped 85 times until it got to 0. So once our condition became false by X being less than 0, and this is where that Boolean stuff comes in, our processing continued to exit. And that's it. That is our while loop. And this is a very powerful loop because this is how we're going to return back and fix our calculator program. We could do that with a while loop, or we could do it with our upcoming switch statements. So now let's continue with one of the most powerful control statements in the C++ language. We're about to talk about the for loop. our for loop has 3 parts that's separated by semicolons. And this is the proper syntax in C++. So you might notice right here, the first thing is X. This is our variable. This variable will be within the scope of the body of our for loop. And we have our condition. And our condition here is, as long as X is greater than 0, we are going to do this action. Our action here is increment X. And if you notice, this is not the behavior we want. So we actually want to decrement X. So this is a remnant from our previous example. So let's change it in the code. When we were using our while statement, and let's put the while statement up here. So as you can see in our while statement, that this line was necessary. But we also have the same line here. So for each of these, for each loop, what we're going to do is decrement X until X is less than 0. So like when X is 0 or -1, we're going to return to line 17 and continue processing right here. So this behavior will actually subtract by 2 because we're going to print this line and then we're going to decrement again on line 15. So check this out. Now this might not be the behavior you want, which is definitely not the behavior I want. So you're going to see how we're going to fix this. So let's run this code. So we're going to enter a start value of 60. And as you notice, our loop is, we are decreasing by 2 each time. So starting off with 60, 58, all the way down to our lower value. We're about to run this again, and this time we're going to get rid of this line, which this line is a remnant from when we used our while loop. So now let's run this again, save and run. And let's enter 60 again. And now you can see we are decrementing by 1. 24, 23, 22, 21, all the way down to 1. And you can see it's starting off at 60. This is the behavior we want. So ain't nothing stopping us from doing that right here by saying X equal X minus 2. So we could take care of all our sophisticated looping right here by assigning X to X equals X minus 2. So let's run this and see what happens. So right here, we're going to say X is 60. And hopefully we're going to start decreasing by 2. And that's exactly what we have. So what is stopping us from saying X minus 20? X equal X minus 20. And we're going to enter 60 here. And there it is, 60, 40, 20. So this is our action that happens for each time we loop through this thing until we get to 0. And that's our for statement in a nutshell. So I think it's time for us to move to the big one here, our switch statement. So now let's retype our poor man's calculator. They will have int xy remainder. I don't even remember the rest of it. So now we're about to use our switch statement. And that's it. So our switch statement basically takes a value here. So this could be anything. And outside of that, we're going to say poor man's calculator. And now we want to enter a value. We're going to say enter first value. And X will hold our first value. This is our first. And Y will hold our second value. So now we got our two variables out the way. And now for our menu system. So we're about to print many options here. So first one is add subtract multiply divide. And we're going to just do modulus as a separate operation too. And since we added, we about to say this option is going to be change numbers. And the last option will be exit program. So this looks familiar, doesn't it? So we're going to say 1, 2, 3, 4, 5, 6, and 7. And now we're about to get our choice. And we're going to work on our switch statement now. So let's put our curly braces here. So first thing we're going to do is we're going to use the keyword case. So in this case, we're going to be using this is going to match the data type of choice. Since choice is an integer value, our cases has to be integer. So we can't have something like case equals the letter D, character D. That won't work. So in this instance, we're going to say case 1. And if case 1, in the case of this answer, we're going to say COUT. And we're going to print X plus Y. And we could say something like result equals of, and we could actually print X and right here we're going to put our plus Y, and this is going to be our equal signs. And there it is. The result of x plus y equals on case 1. And we're going to finish up the rest of this. So let's see what happens when we try to compile this thing. Poor man's calculator. Enter the first number, 4. Second number, 5. So let's add. And there it is. 4 plus 5 is 9. So we're about to implement the rest of this. So we already know that we got case 1. Let's do case 2. I guess we could finish up with case 3. And notice these are semicolons. So the case statement uses semicolons. And you know what that's kind of reminiscent of, right? Yes. If you thought about it, this is just like using go-to statements in labels. And notice this isn't a video on the details of how to use the switch statement, because there are a lot of things I'm leaving out, like the default and all that other stuff, but we'll get to that later. So let's see. So in case 2, what was our cases here? Let's go back up here. Add, subtract. So we didn't change numbers until we got to 6. Add, subtract. And add, subtract, multiply. Divide. And modulus. And now we're gonna copy this again. Because when we get to case 6, we want all this to happen. Now you get to see it. Now you have a chance to see a complex case that spans more than one line. And when you want to span more than one line, we use these curly braces. All right, so now it's time for us to give this thing a quick run. Poor man's calculator. Enter a number, we're going to say 98. Second number, 66. So now let's select add. That's going to be our first choice here. And take a look at the results. We have our add function, subtract. We have all the functions as if it doesn't matter what you select out of add, multiply, whatever. So that's the behavior you get whenever we don't use a break statement in our case. So that's it. So let's fix that now. So the problem we have here is after each case statement, we do not have a break statement. So let's put our break statements in. And what the break statement does is it's going to break out of this switch clause and it's going to continue down to here on the outside of our switch statement. So let's put our break statement in case 2. And I just copy the break keyword so I could quickly do this. So in case 7, this is not necessary. Now case 7, and we could just say something like exiting program. If I can learn how to spell today. So now let's give our program a run, save run with F11, and let's see what happens now. Enter our first value, 745, like a BMW. 441. Now let's add them. And now we have the desired results. But we still can't go back into our program. I want to see what happens whenever so now let's run it with option 6 to change the numbers. So we're going to put in 987, 74, and let's change our numbers. Option 6. And we're able to do that, 84, 332. So that's the behavior we get. So now it's time for us to make it so this thing works in a real loop so we could change numbers and play with different operations. So complex statement. Let's capitalize that. So what we're about to do is we are about to take our switch statement and encapsulate it within a while statement. I highlighted all the code from my switch statement and shifted it over one tab. And this is for our while statement here. And our condition here is going to be while choice is not equal to 7. And I could even put a comment here, start while. And I like how whenever you're using DevC++, how our brackets are lined up. And you could see that something is missing right here. That is a real good feature of using this code editor. So now we have our while statement to trap our switch clause and make it so we could keep repeating. So let's run it now and see if we get our desired behavior. I want you to pause the video and predict what's going to happen when we try to run these results. Enter our first numbers, 745 and 885. So let's add those numbers. So that's not what we're looking for, right? We about to fix it so our results won't be in this continuous loop. So let's fix it. We're going to always set our case to 6 when we're going on the outside of our while statement. So right here, I'm about to set our choice to 6. And that's gonna make it so you are forced to make a new choice. And that's the same thing as saying a default. So check this out. Our first number, 745 again, 85, keep doing the same numbers. So now, that's it. So now, you see we asking for a value again, and now, that's it. So we just fixed the big problem with our poor man's calculator. When we enter a first and second value, and we select an operation like one add, now we're gonna get one result, and we'll jump to line 59. Our while loop will handle our break statement after choosing to add X and Y. And last, we're going to jump to case 6 in our switch statement. And notice there's no way to handle user selecting a different operation. So that's why we stuck in an infinite loop where it's just asking us for 2 numbers all the time. And we're about to fix that right now. So to fix our infinite loop, we're going to get rid of our choice equals 6 at the end of our while statement. And we're moving that to each of the case elements in our switch statement. So in this case, whenever the user selects adding, which is case 1, it's going to default to choice number 6. And we're going to do that for our subtract, multiply, divide, add, all the rest of them. And you notice in case 6, that's the only place where we're going to be setting our choice, and then that's going to dictate our case. And if you select 7, we're going to exit the program. And now let's see what happened when we run it. Enter first value, 74. And we're going to, all right, so we got mod working here. And we're going to do 1, add. So and our program exited. We're going to run this one more time because I really think that this is a This is something you should be proud of. You created a damn good shitty garbage calculator. We're going to enter the number 985, second value 745, like a BMW, and we're going to divide it. We're going to select number 4. And there it is, our results. And now it's going back into the same loop to enter new numbers. So we're going to say 858, second number 740, 7441, and we want to add them, right? So we're going to select 1. 1 for add. And there it is. Our values were 858, 7441. And you can see our values being printed here. And let's exit our program after running it one more time. Let's see which one we didn't do yet. I guess we did all of them. And let's just exit program. And there it is. And you notice when we exit, we don't even see this line that says exiting program. Soon, whenever our case is 7, it becomes 7 before this line is executed. So therefore, we don't even need this line. And we don't need this break statement either, but we can leave it here just for simplicity. So this is it. This is all 74 lines of code to make our calculator work. And one more thing, we don't need this either. What we could do is just set choice equals 6 soon whenever we start our program. And we still gonna have to, oh, here it is right there. So soon we start our program, we could set our choice to 6. When you set your choice to 6, it automatically starts in the mode to enter numbers with the menu. So that is what we consider optimization. When you try to get rid of unnecessary redundant code, or that's refactoring your code. So I just took about 40 minutes of your time with this video. So if there's something that you might need to brush up on, go back through the video, because this was a long one, but it's very important to understand these loops as we progress into day 10 functions. We're about to learn functions today, but before we do that, make sure you hit the like button, share this video, and you subscribe to my YouTube channel. I'd like to start by saying we've been using functions already in our course. And now it's time for us to open up DevC++ and start a new project. And we're going to name this functions. Functions. And that's going to be a console application. So we're going to hit save and do all this good stuff. So here it is. Soon whenever we start DevC++, we are greeted with a function. And this is the function we've been using, main. So now it's time for us to put our user namespace statement in our code. So we've been using the main function since we started with hello world. Let me put a few spaces in here. And we're about to start writing our own functions. So the first thing we're going to do is create our function prototype. That is to let the compiler know that we're going to use this function later. This is normal C++ syntax. Now it's time for us to talk about the function body. And notice main doesn't have a function prototype. And that's because main is a specialized function that deals more with the operating system. Stuff like allocating resources, deallocating resources, a whole bunch of other stuff that's beyond the scope of this course that will be covered somewhere else. So I just want to look at creating our own function, which requires a function prototype. And now it's time for us to move down to the body of our custom function. And as you can see on line 4, that's our function prototype. And on line 12, it's almost the same identical information. And as you see, X and Y are our function parameters. They are basically placeholders for the real values we're going to supply into our function later. and they will have scope within our function. But I want you to notice this integer value z. It has limited scope only within our function body, and scope refers to the lifespan of a variable. And notice the use of the return keyword. We're using it in our main function and in our custom function, func1. And our return type is always in the beginning of the function before the function name. And our return statement is at the end of our function or somewhere in the function where you'll see the return keyword. And that's where the function would return that value or that expression as the result of that function. And now it's time for us to tie all this together. We're going to go back up to our main function and we're going to eventually do a function call. But first, let's create two variables. Let me see here. Value 1, and we're going to create a second one, value 2. Let's give them values right quick. So we're going to say, let's see, 99 value 1 for 99 for value 1 and 62 for value 2. We're going to use these as our input arguments for our function. So that's what arguments are, and that's the difference between arguments and parameters. Arguments are what we're going to supply to our function. They're going to be the real values of the parameter. So let's print something out to the screen. Our function returned. So we're going to do return here, and let's print our function value. So we're going to actually print the value returned from our function. So remember, function 1 has a return value of integer. So that means we could use that as if it was the expression. But first, let's use a result to capture our value. So we setting result to the value returned from our function call to function 1. And we're going to print that to the screen. So let's see what that's looking like. So we have a return value of 161. And let's go back to the code to see what we have here. So 99 plus 62 is 161. So as you can see here, our function is returning the correct value. Functions are extremely important in C++, and wait till you progress through this course and you're going to see exactly how powerful these functions could be, especially whenever we start getting into the second half of this course. So our next video is going to be on arrays, pointers, and references. Yo, you remember the last video? I said we about to have a quiz. This is our quiz. Do you know the difference between parameters and arguments? The answer is parameters are the values we supply to our function when we're defining the body of the function. Arguments are the values we use whenever we're doing a function call. If that quiz gave you a little trouble, then I suggest you go back to day 10 and take a look at functions over. And if you ace that quiz, then I think it's time for you to move on to today's topic. Today we're going to talk about references, pointers, and arrays. I think now it's about time for us to talk about exactly what is a reference. So let's say we have integer x, and we have int reference xr. This is x, and it has a value 63. When we create xr, it's going to refer to our integer value x. So whatever we do to xr has the same effect on x. And that's basically what a reference is. So you're going to see this throughout this example. So just keep that in mind. And we're going to start our favorite compiler here, our favorite IDE, DevC++. At least for right now, because we're about to start switching over to Visual Studio Code soon. So get ready for that. So we start in DevC++. First thing we're going to do is create a new project. And we're going to name our project, which is a console application. We're going to name this console application ref, R-E-F, PTR for pointers, arrays, A-R-R-Y for array. Hit OK. And we're going to hit save on this one. And we're going to get rid of our main function arguments. And we're going to get rid of this. We're about to drop our user namespace std. And now, let's create our first value. Int x equals 98. And the second thing we're going to do is we're about to create an alias for 98 in the form of a reference. And now it's time for us to create our reference. Int reference. And this symbol means reference. This and symbol. XREF. And we're about to set our X reference to X. And that's it. So this is the most important line to understand. We just created an integer reference that holds a reference to the value X. So whatever we do to X reference, we're also doing it to X. And we're about to see an example right now. Let's print our values to the screen. Yeah. So there we have it. So we print now X and X reference. Now let's compile. We see X is 98 and X reference is 98. So let's see what happened if we modify X reference. So as you can see here, we just added 30 to X reference. It changed in both X and X reference. So now we're about to take this same line and we're going to say X equals X plus XREF. So what do you think the value is going to be when we print X and XREF this time? Let's see. So our value is 256 because we just basically doubled XREF and X. And remember, XREF just happened to become 98 plus 30. And that is 108 and 30, that is 128. 128 plus 128 is 256. So our references is just an alias for a value that's already existing. But they have some things you can't do with references, like you can't reassign a reference after it's been created. But one great thing you can do is you can have two references pointing to the same variable. I should have said two references referencing the same value, which is X. So our new reference, XREF2, is on line 10. And now let's print out XREF2 right along with our value X in our first reference so we could see how these values change. All right, so now let's hurry up and run our program. Here it is. X is 256, XREF is 256, and XREF2 is 256. Anything we do to any of these values is gonna all change respectively. Let's see what happens when we increment one of these references, which is, in this case, XREF2. So in this example, we have two references pointing to the same value. And when we increased XREF2, that also changed the value in X and XREF1. And for consistency, let's move XREF2 up to the declaration part where we declare all the rest of our variables and references. So there we go. Don't that look better? Now it's time to talk about pointers, one of the most powerful features of the C++ programming language. Let me show it to you in code. So this is how we declare an integer pointer. And now let's drop it down the line. And we just created us an integer value that we're going to be using throughout this example. Let's set x to 61. And let's move this pointer's comment down to line 8. So now, let's assign our pointer to one of these values. So let's set our x pointer to our variable x. And let's compile and see what's going to happen. So as you could see, we got a compile error. And the reason why is because we didn't use our address operator. It looks just like the reference operator, but in this case, we are talking about address of. So what we are doing is we are setting xptr to the address of x. So now let's print the value of our pointer using the cout statement. And I'm going to tell you ahead of time, we will not be printing the value 98. This is going to give us the address of xptr pointer. So in order for us to print the actual value or the data that's in our pointer, we're going to have to rely on another operator. The start operator is known as the dereference operator, and this is how we get the actual value stored at our pointer. Now it's really time to start playing with some power. Let's reassign our x pointer, this time to point to the address of variable y, as you can see on line 7. And let's copy this down to line 13. And we're going to print the value of the address of x pointer so we can see how it changes. And we're going to see how our dereferenced value changes. And now let's see what's going to happen when we compile it. Alright, so now it's time for us to start taking a look at the results from this code. So first we're going to start off by looking at the fact that we assigned x pointer to the value x. And x has the address of this 0x78fe 14 ... So that's the memory address location. And let me draw that on the screen. So now, whenever we call our pointer with the dereference, we are actually looking at the value that's stored in the value x. So x and the pointer are both pointing to the same memory address that holds the value 98. So then on line 12, which is something that you can only do with pointers, not references, we are about to reassign our pointer to another value. So we are assigning it to the number, to the variable y here. So y has an address of this same 0x hexadecimal, yada, 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 and it ends with the number 10. And the data in that address is 61. So our two values now is x with 98 at the address 0x something something 14, and our y has the value 0x78 and ends with 10. So our pointer could be readdressed, and we use the dereferencing operator to get our value from the pointer, and we use our address to find the physical memory address, which is represented in hexadecimal here in C++. So hexadecimal is a 16 numbered, a base 16 numbering system with 16 unique values. Just like we use our decimal 10 base system, and like you can't have no more than 10 numbers before you start repeating. That's why the number 11 is 1, 1. So I'm gonna have a video on my channel explaining that, but I think it's time for us to move on to arrays. All right, so first of all, this is how you declare an array. We're gonna start off with our type, and then our name, and then we're gonna have these square brackets. inside the square brackets will be an optional size of the array. And size is just a way of just saying how many elements we're going to have in our array. And when we declare this array, we're going to use the size of the array being the number. We could just go with 4, I'm guessing. There we go. So now let's point to all these elements. So there it is. Our size of the array is 4. This is using all those elements. So what an array does is point to a specific area in memory, and it's going to declare a block of memory to hold 4 values. And remember, array counts start at 0. So the first element will be x of 0, or the element x0. So look here at line 8. This expression 2 times the value of x of 0 is 0. So when you see this, just know that that's 0. So that's why we're going to just put it in our array. So x of 0 is 0. And we got x of 1 with 32. And let's put our x of 2 here. 982. And x of 3. Let me think of a value here. 8,298. So here's some optional one. This money. We're going to just throw a value that we know won't work. So I just want you to see what happens when you try to address a value outside of the bounds of our array. So we're about to experiment. Now let's start with this for loop to loop through the elements in our array on line 14. And the purpose of this line is to print all the values in our array. So you already know if you try to run this program with this line 12 money looking like this, it's going to give you an error. So let's fix this issue. First, what we're going to do is just declare money to be an integer value. And we're going to set it to 92. And now, watch how beautifully our program runs. See that? And you might notice that 92 isn't printed out in our results. So we're about to go into our for loop and make it so instead of having 4 values, we're going to make it so it's going to print 5 values. Because remember, arrays start with 0. So if you include 0, that is a count of 5 elements, starting from line 9 to line 13. 5 elements. And now all 5 of our values just printed. So we covered a lot in this video. We just got done discussing arrays. Arrays is a big thing in C++. So we're going to talk about that more as you progress through this course. I don't know if other languages could do function pointers, but I'm going to tell you like this. C++ and C are 2 languages it can. So this is some powerful stuff. This is one of the reasons why C++ is a powerful language. Not to mention C. We're not talking about C here. Don't worry about C. We're talking about C++. So it's time for us to get this thing started. So what is a function pointer? A function pointer is a mechanism that allows us to address functions by using this pointer. So just like a reference points to a value in memory, a function pointer points to a function in memory. So that is a detailed discussion for another day on how these functions even reside in memory. But just look at it like this. When you create a function, you create a call stack and you have an address for where that information is going to be stored, where the procedure will start. So now that we got that out the way, function pointer. So a function pointer will have the same look and feel as the function we call. Except to declare a function pointer, you're going to have these 3 things. First, you're going to have the return type of the function. That return type must match the function that we're going to be calling. Number 2 is the name of our function pointer. And number 3, the parameter list. The parameter list will not include values like X, Y, Z. This will only be the return types. So this is an example of a function pointer. This one is going to return an int. And the name of it is FPTR. And it takes 2 integers. That means we compare this to any function that returns an integer value and takes two integers as input. Now let's discuss how our function pointers work. So I'm creating the function pointer right here, and it's called fptr that takes two ints. So now right here is our function called cost, and it takes two integer values, x and y. And notice the dots at the end. That just means this is where the body goes. That's not important right now. So I want you to notice the return type of our original function cost and the return type of function fptr. Both of them are integers. And now look at cost taking an x and y as its parameters. That means we're taking two integer values. And look at the function pointer. It also takes two integer values. The only difference is we don't have any values or any variables. We don't care about variables when declaring our function pointer because we're going to do that when we make our function call using our function pointer. And this is how we set our function pointer to our function cost. And this is how we use the values in our function call. We're using 6 and 57 as the input values for our function. And now let's recap what we just discussed. So first we're going to create our original function called const. And I'm declaring our function pointer fptr right here. And this is how we assign our function pointer to our function cost. And now we're evoking, or we are hitting a function call using the input values 6 and 57. So function pointer is pointing to the function in memory where cost is. So let's say cost is at the memory address of 7072. Our function pointer is going to also point to 7072. That's it. Now it's time for us to start DevC++ so I can show you some examples of these function pointers. Just the notes here. Function pointers. Okay, we're going to go up here to File, New, Project, and we're going to select Console Application like we always been doing. And we're going to name this thing Function PTR, Function Pointers. Clear this out. So now we're going to get rid of this crap. That's going to come later whenever we start talking about the int main, our main function parameters, but we're going to leave that for another video. Let's put our username space std statement in here. So when I learn how to spell it, there we go. All right, and we're going to get rid of this junk, this comment. So now, let's see, we're going to name this function pointers. Function pointers. And now it's time for us to create a function. We're going to create three simple functions that we're going to play with here. So our return type int, and we're going to have our add function that's going to take two integer values x and y. And let's put our body here. Last time you saw this is I used ... for the body. That just means etc. So now instead of using ... we are actually defining a body. So we're going to run our sub here, sub for subtract. We're going to use our same parameters of x and y. And we're going to return x minus y. Don't forget the semicolon here. And let's do one more multiply. M-U-L-T for multiply. Same parameters here, x and y. And let's put our return type, let's run our return of x multiply y. And that's it. We have our three functions ready to roll. So let's start our main body, the body of our main function here, and we're about to print some stuff here into a first value. So we enter in our first value right here, and we're about to create a value to hold a variable to hold our first value. So we're going to name that value 1. And we're going to just create 2 because we're going to be inputting 2 values into our function. So we're going to be using 2 variables. So now we see we are using our cin statement to place the user input into value 1, and on line 14 now, let's put our second value. We're about to get our second value, and ENDL for inline, and now CIN value 2. That just means we putting our input in value 2. All right, so we got a little more here. Put our comments here now. Let's LETS create our own function pointers. So pay attention to line 17, because we are about to create our function pointer. And remember those 3 steps. The first step is the return type, and our return type here is integer. And this is our function pointer. And notice function pointers has the asterisk and the name of our function pointer. So what's the name of our function pointer? Operation. So operation is the name of our function pointer. And now for step 3, our function pointer will take 2 int values. Notice we don't have integers here. We just have the return types, just int. When using function pointers, we do not have to redeclare our parameters. So our parameters are defined in our compatible functions. In this example, we have add, sub, and multiply. They both have integer return values. So we assign our function pointer to a compatible function using the assignment operator. You're going to see that later whenever we do our function call, using our function pointer to point to one of these functions. So here's the result. Now I'm about to print out our add function using some values. So our add function will take on 2 arguments, value 1 and value 2, that's going to be supplied in our CIN function from the user when we run the program. So now it's time for us to assign our function to a compatible function using the assignment operator. So first on line 19, we're about to assign our function pointer to the address of the add function. So let's make up some addresses for our other functions. We got add at 46, sub 66, and multiply at 86. Those are the addresses. So if you notice, we didn't use any other symbol. We just say operation equals add, because function names are really just pointers. We are pointing to the memory location where the function resides. On line 19, we are assigning our function pointer operation the address of our add function. And on line 18, we are supplying 2 arguments to the add function. Now let's perform a function call with our function pointer. Take a look at line 20. We are using operation as if it was our add function. Check it out. Operation taking on value 1 and 2. It's the same way we did when we did our original function call on line 18. That's the beauty of function pointers. So let's compile this and see what we got here. All right, so, and here it is. So let's put in 87 and 74. And notice, on line 18, that's where our results came from. And then line 20, that's our function pointer using the same function, just a different name. And notice both of them produce the same results, 161. That's how simple it is to use function pointer. So we're going to change this to tax. We all know taxes are something we do not like to give our money away. And right here, girlfriend shopping. Any women watching this video, this is nothing against women, but sometimes, we try to make this realistic here. So when you take your girlfriend out shopping, it's most of the time gonna involve you spending more than what you budgeted. So our function is about to reflect that. So line 19, we are assigning our operation function pointer to GF shopping. And let's change up here. So return 0. So what we're saying here is no matter what you put in here, let's say you have 2 bank accounts. X and Y now represent 2 bank accounts. Yes, X and Y are our new bank accounts. So look at that return. We return a negative $890 because no matter how much money you go, how much you budgeted to shop, when you're doing it with your girlfriend, she is gonna drain your wallet. Don't unsubscribe to my channel, ladies. Y'all are beautiful. So we about to take our girlfriend, take my wife, girlfriend, wife. You know, when you my age girlfriend, that sound immature. I'm a grown man here, so I'm taking my lady shopping. So let's see what she gonna do to my wallet here. Bank balance. Let's see. So our bank balance. That's instead of wallet, we're gonna use bank balance after I took my lady shopping. So let's see what's gonna happen here. So remember, X and Y are our bank balances. We have two bank accounts. We tried to be slick and hide it. So you have 74,000 in one account and 5 something in the other one. And look at what happened. After all that, you still have negative 890. So the argument you feed to this function don't matter, because no matter how much you got a million, but you know, I guess, yeah, we ain't gonna talk about negative numbers right here. That's gonna be saved for another video. So let's see taxes. So in the state of swampland, our tax rate is 23%. So this is how you calculate your taxes. So we're gonna multiply the money we have in our two bank accounts, X and Y. And so there we go. So we're gonna say the sum of our two bank accounts subtracted by the sum of our bank accounts minus 23%. So let's add up our bank accounts again right here, X plus Y, and subtract the taxes, which is which is calculated right here on line 6 right here. So it's calculated by multiplying our bank balance by 0.23. So instead of using money from work, instead of using two bank accounts, you can say, hey, you got 2 jobs. You got to have 2 jobs to take some of these women shopping here. So you better make sure you know what you're doing. So total money. Oh, this video is not gonna do well. So our total money here, that's gonna be just a basic add. So we adding up our money from work or whatever I said. What did I say earlier? That's our 2 bank accounts. Whatever we got, we're gonna add value 1 and value 2. You can define whatever you want to call value 1 and 2. So that's it. So right now we're about to assign our operation tax. And let's see what our value looks like after our taxes. So that's gonna be after taxes. And now I'm taking my girlfriend shopping again, my latest shopping. And we're gonna have to reassign our function pointer one more time. So line 19 is whenever we assigned it to tax. And on line 21, we about to take our girlfriend shopping, our lady shopping. So this is a good example of reassigning a function pointer. Now let's run this thing and see what we get here. So look at that high balance again, 74,000, and there it is. So we have negative 890 after taking her shopping, and after taxes, you can see our value is 60,990. That 990, yeah, that's it, 60,990. So function pointers are very powerful, right? You can do a lot of stuff with this. So it's time for us to wrap this video up. Don't want to make it longer. I'm rambling right now, so really you could cut this off at this point and go to the next video, but function pointers are important in C++, so that's really all I wanted to say. So stay tuned for the next video on Structs. All right, now it's time for us to jump into DevC++ so we can start looking at the implementation of our structs. So in DevC++, go to New Project. We're creating a brand new project, and we're going to name that project Structures. Let's type that in right quick. Structures. All right. And that's going to be a console application. So let's select console application right here. And if this pops up, just hit save. And now it's time for us to get rid of the command line arguments in our main statement. We're going to talk about that eventually, but let's get rid of those arguments. And that other line with all that other BS in it. And now it's time for us to put our user namespace std statement in our code. That's what we use to get user input. Like we said earlier, a structure is a way to model an object. So a structure allows us to group multiple data types like ints, booleans, floats, all that good stuff into one convenient structure. And whenever we put our data types into that structure, like our floats and ints, we're going to be able to refer to that structure by its name and then create instances of that structure. It's kind of like the cookie cutter idea. We create our cookie cutter and then we start creating cookies. Let's look at our cookie cutters in a more formal way. We're going to look at it as a mode. Our mode creates several copies of the same thing. And this is our cookies here, also known as instances. So if the cookie cutter has an int x and y, so that means that each of our instances, C1, 2, 3, will also have an x and y component. So all copies or instances will have the same variables. So instead of creating cookies with our factory, let's create college courses. So we're going to model a real college course. At the University of Swampland, there's this English course called English 1110. 1 hour course that is hard as hell. That's what we're about to copy today. So don't be like me and fail it 6 times. So this is how we create our structure. You notice the struct keyword? That means we're in business. So we're going to start off with the name of our structure here. And it's going to be named course. And each course will have a course name, an integer value that holds a course ID, and a course capacity, how many people could fit in the classroom, a course cost, and the last element will be, is it a graduate level course? And I guess we could look at this factory. A course factory is called the university. Our variables are within the curly braces, and it ends with a semicolon. Let's clear the screen. Now let's describe our variables. Right here we have our course name that's going to point to a character array. And our course ID, that's a 6-digit number that's used to identify our course. Course capacity is the maximum amount of students we can have in this course. And our model course will end with this Boolean value is graduate level. We're going to set it to a default value of false. So these are all the attributes in our structure called course. Now it's time for us to take our course cookie cutter and create some real courses. In the next video, we're going to get into a more formal terminology than using cookie cutter in fact. So let's declare an instance of our course. First, we're going to start off with the course structure name. And then we're going to put our name of our course, English 111. So now that we have our name of our course, or our instance of our course, we use the dot operator. Yeah, I said dot like that. We use the dot operator to access the individual components of our structure. Dot course name, dot course ID, and dot capacity, and dot course code. So what I'm saying here is, once we create an instance of our struct, the dot operator allows us to access the individual components like course name, course ID, course capacity, course cost is graduate level, all the things that we declared in our course structure. We use the dot operator to access that stuff. So what we are saying here is that English 1111 is a course and it has all these components, course name and all this stuff. And it's only English 1111. So we can't create something like instructor name. I'm sure you heard the way I talk. I don't think you want me teaching your English class. So we cannot create variables that doesn't exist in our original struct, like instructor name. So let's create a second course here. So we're going to call this one Janet's course because Janet will be teaching this English 111. So one day you might look back at these names and be in 111 and wonder who is teaching this course. So names like Janet Ing 111 is a better name because it adds a lot more information. Now we know who is teaching this course. It's kind of like the idea I was trying to do, but there is not an instructor name variable, so I won't be teaching this course. Let's get back to the course name. It's still going to have the English 1111 because that's part of the fields in our structure. So notice on line 7 where it says character, pointer, course name. And then line 18 and 25, we are assigning course name the characters English 111. That is an array of characters. We declared memory on the spot when we did that. We're going to talk more about that later, so let's move on. Course ID is next. That's a 6-digit integer that we're going to use to uniquely identify our course. So notice line 19. The course ID is 873291. We can't use that same number here on line 26. And now, Janet's Ing 111, we're about to access with our dot operator the capacity. And we're going to set our capacity to 100. Janet will be teaching a big auditorium style course. On line 28, we about to set is graduate level to the same variable as Ing 111 is graduate level. And it's going to be false in both of them since we're using the same value. And now it's time for us to create a function here. Our function will take a structure and print the values. That's all it's going to do. Let's start with our return type, void. A void return type just means that our function will not return a value. And notice our input parameter, course. Just like in Boolean or some other type of parameter, we are accepting only course structures. So it's time for us to start printing these values. And notice on our line 16, input course, dot course name. We are using the dot operator on the input variable. It works just like any other thing. If we had int x, then we are accessing int x. So using a structure is one way that we can return many data types or accept many data types into our function. So line 19, we are still continuing to print the components of our input course. And now let's finish. Now let's finish up with our coast to coast. Put our inline here. Next, so you got your degree. Now it's time to go to grad school. You're taking a grad course, huh? Well, in C++, whenever we print Boolean values, it's going to print 0 or not 0. So look at our results after running our program. Remember, hit F11 and check it out. We have our course name, English 111, course ID that matches English 111, course ID, and all the rest of our values are printed. But take a look at the Boolean value, graduate course, 0. So that means it's false. And look at graduate level in our code. It says false. So that's what I mean by Boolean prints 0 if it's false and 1 for true. Now it's time to move on and print the course details for my girl Janet's English 111 course. And we're still going to leave the original English 111 course information up here. So let's take a look at it. So as you can see, the course IDs are different and the price and capacity is different. But take a look at that price, the cost. The cost of this of Janet's course is expensive. I guess Janet Jackson is teaching it. So now it's time for us to move on to another example where we're about to declare a struct a different way. So first, I want you to notice the type def keyword. Type def is just meaning that we're defining a new type. So we're going to start with type def, and then we're going to put our struct keyword immediately following type def. And then after the closing bracket, we're going to put the name of our structure. We spelling course with a capital C now, and check this out. C21. We giving our structure 2 names. So we could declare structures now with both names, course and C21. And now it's time for us to see this in action. Since we changed the name of our course, Now it's spelled with a capital C. We have to change it in our function. And now it's time for us to take a look at what we're doing here. So this is how you declare a struct using this second method. Type def struct, put our variables in the middle, and then you notice we have our course spelled with a capital C and our alias C21. So on lines 27 and 34, notice how we have lowercase c's for our course. We changed that to a capital C. So let's fix that one on line 27. And on 34, we're about to use C21 the same way. And let's see if our function's gonna work. All right, so let's capitalize this C and get rid of all this stuff. We're gonna change this to C21. All right. So let's compile and run and see what our results look like here. So our results showing that everything is exactly the same. So we declared one using C21 and we declared another course using course. And it performed the exact same way we expected. That's the beauty of using structs. So let's review structs again right quick. We basically use the struct keyword and then our structure name. And we're going to put our curly braces and our variables in the middle of the body of our structure. And then we're going to end with a semicolon. The second way we declare structure is use type def, struct keyword. And then we're going to put our variables in the middle of the body, just like we did last time. And our struct name will be at the end. And then any alias will be at the end. Those aliases work almost like references in C++. So, in this example, we're about to create two incompatible structures. We're going to call one car. Car is called Bonneville. And that structure will be separate from our phone structure, which we're going to use our second method. So we're going to create V60 and V70 to mess with easy computer solutions. So we cannot assign a Bonneville to a phone. That's two different structures. So this video is finished. We learned about structures today. And tomorrow we're going to learn about classes. And you're going to get a chance to see how closely related classes are to structures. Structures are some old C language stuff. So it's one of the reasons why C++ is such a powerful language. When you program in C++, you also have the ability to use the things that's in C, like structs and all kind of other C stuff. So we're about to get into classes tomorrow on day 14. This is day 14, the first day of this 3-part mini-series. And this is going to be a short one. I'm just going to tell you right now, off the top, there's no big difference between structures and classes in C++. So, how is that? How are structures in C++ and classes the same thing in C++? So back when structures was first introduced in the C language, it had limited capabilities. That means you didn't have constructors, you didn't have polymorphism, inheritance, you didn't have all the other stuff we're going to talk about in later videos. Structures were just a way of grouping multiple data types into one convenient package. That's why I introduced that in the last video. So in this video, we're going to examine the differences between structures and classes. And we're using an old book from 1978 so I could bring home the point. The big difference between structures and classes is accessing using public and private keywords. But when you look at the C programming language keywords, there isn't public and private. So that's why I said a lot of that stuff, meaning polymorphism, constructors, and all that stuff, that didn't exist until C++ came along. So looking at our C++ keywords, you notice we have public and private. Structures, by default, has public accessibility. That means the components of the structure, value X and value Y, can be accessed anywhere in our code. And when we use classes, we have private access. So that means we cannot access X and Y directly. We would have to use a modifying or an accessor function to get the X and Y. So let's see that in code. So here's the normal stuff I always do. Create a new file, new project, console application, and we're going to name it class instruction. Let's start writing our code here. We're going to start off with our IO stream using namespace std line. And our first class, we're going to name this thing box. And our box is going to have two int values, x and y. And now let's move and create our structure. Structure will also have two ints, x and y. And that's it. And notice our box and our square look identical. So let's see why we can't use these in the same way. So let's finish up with our main here. So we're going to create an instance of our box and name it B1. And we're going to create an instance of our square and call that S1. So we're gonna assign values to B1, X will get 98, and S1, X will get 145. So now let's access our B1X and S1X using printout statements, cout. So there's our B1, and let's work on our S1. So what I'm expecting is to print these values without a problem. So let's compile our program and see what happens. What? We got an error. So remember at the beginning of the video when I said classes, all members are private by default. You notice we haven't used the specifiers private or public. So here come our brand new keywords. We're about to use the public keyword to make it so we could access the members of our class. Because remember, by default, even though you don't see the word private in our class, that X and Y is private. And we fixed that by using the public keyword. And to bring this point home, watch what happens when I make it so the structure members are private. Watch this. So now it's almost like our error message swapped. So now it's the structure that doesn't allow access to X and Y. So to get structure-like behavior out of our class, the only thing we have to do is put our public keyword in our class. Or if we want our structure to have our stuff private, just drop the private keyword in our square, and now we're able to emulate the behavior across both structures and classes. There's another grouping called unions, but we don't have to talk about that. So that's the difference. One keyword makes the difference. By default, classes are the members of a class are private, and the members and the data in the structure is public. So it's time for us to get into our treatment of object-oriented programming. All right, so let's get our mouse over here to DevC++. And we're going to create a new project and call it Day 15. Now it's time for us to start writing our code. First thing we're going to do is drop our user namespace std line. Next, we're going to get rid of all this crap in our main function and just make it simplified. Eventually, we're going to talk about argc and argv, but for now, let's get rid of it. Let's bring our code down a little bit. So line 3, we're about to put some comments in here. We're about to create our class. So we're going to use our class keyword. It's standard practice to name our classes with a capital letter. So we got our box here. So now let's work on our constructor. And a constructor is a special function that's called whenever we create an instance of our class. We can look at the class as the cookie cutter and the object is the cookie. So in C++, when we create an instance of our object, it's called instantiation. So we're going to print this cout statement that's going to print the word box constructor whenever we create our box. And this is to show you that the constructor is called. A lot of times in object-oriented programming, we will not waste a lot of space by spacing out our code. We will go with more of an inline technique. So inline code just means we're going to put everything on the same line. So this is not inline, but I'm about to fix this and show you what inline code is. So This is inline. And notice everything is on the same line. That's it. Just to save space in our class. So let's create a box. In our main function, box B1. That's the name of our box. Now let's go back to our box class. And we're going to put our public and private labels into the code to differentiate the sections of our code. And now let's compile it. So as you can see, our box constructor is printed in the results. Now that we just tested our code, let's go back and clean it up a little bit. I'm going to indent our constructor and let's start putting our private data in our class. So we're going to call our Y value Y height and our X value X width. Now let's move our constructor comments down on top of our constructor here. And now we're about to start talking about the destructor. The destructor could be looked at as a garbage can. Once our object is out of scope, and scope just means it's not being used, the destructor is automatically called and box destructor will be printed on our screen. On line 25, our box is created. And when it's created, it immediately hit the constructor. So that's why we have line 12, box constructor being printed. And immediately our box went out of scope. So line 14, box destructor, was called immediately after. There's nothing in between, no code to execute. So that's why it looked like it was an in and out thing. So now let's create some methods. Methods are functions. They serve the same purpose, but in object-oriented programming, it is called methods, or especially if you're doing Java programming. So let's create our getHeight method. This is going to have an integer return value, and let's work on the body of this function or method. So we are just going to return the value of our private data called Y height. And that's why it's named get Y height. So we're going to do the same thing for get X width. We're going to return X width, the private data. And that's how we access private data, because we cannot access private data directly. We have to use a public method. And you notice these methods are within the public section of our code. So now let's move on to our two setting functions here. We're going to create one called set Y height. And notice the return type is void. On line 19, we are creating a method called set height. And this method will not have a return type like lines 17 and 18. You notice we are returning Y height and X width. And we are using the return keyword. So now let's finish implementing our void method. So let's start with our input parameter. Will just be the word input, and it's going to be an integer value. And we are about to set our private data Y height to the input value we supplied. And let's do our next method, void set X width. Same thing here. Our input value is going to be input, and notice we could use the same value input in both of our methods, because each method, set height and set width, will have its own version of our input variable. So this is the savage scientist coming at you in post-production. Instead of using input twice on line 19 and 20 for the parameter on our set height and set width methods, I could have used input X on the set width method and input Y on the set height method. So now let's look at the body of these two methods. You notice we are using the assignment operator, the one that looks like an equal sign. So we are always going to set the left-hand side is going to get the value from the right-hand side. So we are setting Y height to input. The ultimate goal of this method is to assign 5 to our private data Y height. So let's continue. So we're going to create our box B1, line 32, and we're going to drop down to set its height. We're going to set our box height, or our Y value, to 87. So we're about to perform many tasks in our next step in this statement. Starting on line 34, we're about to print our box height. We're about to put the text box height on the screen. And let's get our box height using the box height function, get box height function. And we're about to print the words box width. And let's get our box width. I'm going to eventually go back and use the function b1.set x width, and we're going to give it some value. And we're about to print the area. To print the area, we're going to multiply using our get width and get height functions, and that's going to give us the value of those two, or give us the product of those two. And remember, in mathematics, when you multiply two numbers, it's called a product. There's a bug in this code on line 35, and the hint will be looking at lines 17 and 18. I want you to pause the video, figure it out, and then unpause, and I'm going to give you the solution. Alright, so let's solve this problem. So the get width function and the get height function doesn't exist as I wrote it. So it's missing the x and y part. So we're about to change this to get x width and y height. So now on line 34 and 35, get x width and get y height methods are matching just like they should when you look at lines 17 and 18. So now it's time for us to talk about setting our width. And I want to mention the dot operator. The dot operator is what we use to access methods from our functions. So notice, we're always going to start off with our object, which is B1, and we're going to put a dot here. The dot means we're about to call a function. And normally if you have a compiler, a very smart compiler, it will list all the functions or all the methods associated with that class. Our class is called box and our object is B1. So on line 34, we just got done setting the width of our box to 144 using our set width method in our box class. So now it's time for us to run our program. So remember in the beginning when it just printed box constructor and box destructor? Now in the middle we have our box height equals 87 and our box width 144. And for the area of the box, you just multiply width and height. That gives us 12,528. And notice our box destructor follows because it's out of scope. So we just discussed some of the basics of object-oriented programming. And this is our class. And normally we would take our class and write it to a header file. And normally that file would then be a .h.hpp, one of those extensions. And then we go and use that later in our code. So we're going to discuss header files more in the future. So this is the Savage Scientist Ed on day 15 of this C++ journey. What's up, folks? This is the Savage Scientist Ed, the governor of the great state of Swampland. And this is the 16th day of our C++ in 31 days series, and the third part of the object-oriented programming section. And today we are about to take a look at more object-oriented programming. And in the last videos, we played with objects, manipulated objects, and went over structures and classes. So those videos are available if you need a little refreshment. So in this video, we're about to look at creating classes and separating them into implementation files and header files. Now let's talk about our header files in the C++ programming language. A header file basically implements an interface, and an interface is a stripped down version of our class that doesn't have the implementation of the methods. So we could look at a header file as having a .h or the newer .hpp extension. And when we implement the body of the methods, we will do that in a .cpp file. And we don't use .c often. That's normally something back from the C programming days. So nothing stops you from using the C extension in a C++ program. Now, when you start getting into real C++ programs, you might run across this statement, pragma once. And what this statement is a very basic statement that says we do not want any redundant code in our project. So this statement is in a section where we have all our include statements and preprocessor directives. And this is the preprocessor directive. We're going to have more preprocessor stuff in a future video. So pragma once. This is telling the compiler to only include this object called box one time. So let's say this is our project. And we call in box in 1, 2, 3, 4 of these files. So to avoid having redundant calls to box, so we would have pragma once in one of these files. So the magic of our pragma one statement happens when we have duplicate calls to our box object like in these other 3 files. And they will automatically be ignored because we already have it declared in the file that has the pragma one statement. Let's hop into DevC++ and get this thing started. We're going to start with a new project, and we're going to name that project Day 16. We're going to set our save point to the folder on the desktop, and hopefully you should have folders created with all our days, day 1 through 31. If you haven't done that, then create 31 folders for our work, and for each project, save it in that folder. So we're doing things a little different today. Instead of working with our main file today, let's create a new file. So we're going to go into our project and select the new icon and then source file. And we're going to name it box, B-O-X. And we're going to select the header file from our dropdown. So we're going to name our header file box.h. And let's repeat the same process and create another file called box.cpp. That's going to be our implementation file. And up here we have 3 tabs so we could switch between our files. We have our main.cpp, our box.h, and our box.cpp. I'm about to show my age with this one. I remember back a long time ago in 1998 when I was learning how to code. I did my Java programming in Emacs, and we didn't have all these fancy tabs and all this stuff to make things easier. So for the people who are learning the code today, y'all got it easy. Now that we got that out the way, let's start working on our box.h, our header file. We're going to put our include IOStream statement in on line 1, then let's go to line 2, using namespace.std, and we're about to start creating our class here. So we're going to use our class keyword with our box, and we're going to open parentheses, and this is the public part of our class. So our public method is going to be our constructor and our destructor. And our private, we're going to just put the private keyword here, even though we're not going to declare any private data. And we're going to close our class off and put our parentheses here on line 10. And that's it for our interface. And as you notice, there's no implementation of our constructors. And now it's time for us to move to our box implementation file. That's the box CPP file. We're going to start with our include box.h. And what that does is allow us to have access to our interface box.h. And we're going to use our scope resolution operator to have access to those objects in the box, or to have access to the scope of the box. And we're going to just implement our constructor and destructor. So whenever we create our box object, it's going to print box constructor. And let's work on our destructor here on line 8, putting our box destructor here and some code that's just saying box destructor, line 10. This is how an API is born. An API just makes it so other coders could use our code. And now let's work on our main CPP file. We're going to also include our box.h. And let's see. So we're going to create an instance of our box and let's run it. That's really all this thing does. So the purpose of this exercise on day 16 is to demonstrate creating an interface. Our box interface is box.h, and it only has two methods, the constructor and destructor. And the body of the constructor and destructor is located in our box.cpp. And you notice we don't call our box.cpp directly in our main function. It is done through box.h. And that's the way an API works. So you should rewatch this video before moving on to our later lessons. This is an important video on object-oriented programming, and we just implemented our own API. So we just wrapped up day 16. So give yourself a big salute. You are more than halfway done with this C++ in 31 days series. I'm gonna have a separate video on using Pragma 1 and other preprocessor directives. There's always an exception to the rule. And today we're gonna learn how exceptions work in C++. What's up, folks? This is the Savage Scientist, Ed. And today we're gonna talk about exceptions. So we could look at an exception as a way of creating a customized error for the compiler to catch. In a C++ language, we could create exceptions that's going to handle cases like dividing by 0, or if the range of a variable is outside of the scope that we declare. So it's time for us to start learning exceptions in C++. All right, start DevC++ and go to File, New Project, and Console Application. And we're going to name our console application Day 17 because this is our 17th day C++ program. And then we're going to open up, we're going to save our project in our Day 17 folder, hit save, and there it is. Now, first thing I'm going to do is add our user namespace std line. This is the order of our topics today. We're going to use our try keyword, and we're going to use the throw keyword, and I need to learn how to spell catch keyword, and we're going to play with debugging using print statements. Let's get rid of this. Are you ready to get into our coding? I am, so let's start. We're going to just move our brackets down so it can match the style that I've always been using block style. So line 10 and line 13 indicates our block, our code block. So let's create an integer, and we're going to name it X, and our try statement, or our try block. So we're going to try if X is greater than 10, we're going to have a successful program here. That means that's what we want. And with exceptions, we are really working on catching errors in our code or programming logic that the compiler will not catch. On line 16, let's start our throw statement. So the word invalid value is actually a constant character array. In this video, I'm probably going to keep calling it string constant, but it's actually a character array. Depending on our throw statement, will determine what our catch statement is going to look like. So we could have thrown an integer or a Boolean value. So like I said earlier, starting on line 12, we're about to start our exception handling with our try statement, just meaning that this is the beginning of the exception handling process. So line 14, if our X value is greater than 10, we're going to throw the exception saying invalid value, which is a constant array. So another way of looking at this is the name of the function is throw. The argument for the function is invalid value. So throw just means we got to pass it to the exception handling procedure. So if x just happened to be less than 10, we're going to continue executing and we're about to proceed with this else statement. And here we will just print successful. And we're going to print the value of x here, x. And our inline. So we have our if else. So now it's time for the magic to happen with our catch statement. And we're going to print out our constant character. So this is like a loop that listens all the time for anything that passes through on our throw statements. Constant character. So down here on line 23, error is the value that is thrown from my exception, and it has to be a constant character array. So on line 23, we could look at the catch statement as a general function that's going to take all the thrown exception messages, like the one on line 16 where it says invalid value, that is going to get processed on line 23. If we have a invalid value where x is greater than 10, that's an exception to the rule, right? So we're going to just deal with that right here in our catch statement. So our catch statement here. So now let's assign x a value that's greater than 10, like 99. Let's hit F11. So now we have an invalid value. So our our error message is invalid value. And that is thrown because x is the value 99 is greater than 10. So let's see what happened whenever we just put 9 here. So we have a successful value because 9 is less than 10. That's all our exception does. And the reason why we're using these print statements is so we could see exactly what our exceptions are doing. And now it's time to continue with another example. So we're about to check for null values. So first thing we're going to do is we about to create another integer value called y. And we're going to set y to 0. And as you know from our previous videos, 0 and null are the same thing. But in C++, it's always good practice to set variables to 0. So let's continue working on that. And let's change our if statement on line 15 to say if y equals 0, we're going to show invalid value. Let's compile and run our program. And we have an invalid value being printed. And that's true for a function because if you divide by 0, it's going to be undefined. So that is exactly the behavior we want when we divide in two numbers. And the example would be, let's say we have 8 divided by 0. The answer would be undefined. So that's the basic idea of what we just did. And if you try this with the compiler without catching this error, the program is going to try to run, but it's not going to give us the results we're looking for, and we're going to have an exception. So now let's play with this example, and I'm about to show you what the compiler is going to do if we try to divide by 0. So we're going to create this new variable called result. And we're about to divide x by y. And let's compile it. This is the solution we got. Nothing. It didn't print anything. And that is definitely undesired results. So if we comment out this line, everything is going to work the way it's supposed to, because we about to catch the reason behind we about to catch the logic behind why the program stopped running. But let's see what's going to happen when we create a constant. A constant is just a value that we know will never change. So 9 divided by 0. So when we use 9 divided by 0, we got the same nothing in our program, but check out what the compiler did. It produced a warning, division by 0, or you can't divide by 0. Our warning is on line 13. In DevC++, when we highlight the exception or error, it's going to bring us to the line and show us where the error is located, or exception. And it's with this 0. This makes it so the compiler is going to throw an error that's going to crash our program. That's why it's important to be aware of exceptions and use our print statements to help with debugging our code ourselves. I have one more example that's going to blow your head off. So watch what's going to happen when I set x to undefined. And remember, this should be a null value. This should be 0, right? So on line 16, we're going to change our y to x and use our comparison operator to see if it's 0. And on line 13, we're going to comment out this line because this line crashed our program by throwing the exception divide by 0 with this constant 9 divided by 0. So check this out. Using this compiler, it said x is 55, but x isn't even defined right here. So let's put a print statement here that's just going to show what our values are. X equals. Print x and y equals. And we're about to print y. In line statement. And now, let's see what happens. So here's the result. X is 55 when it's undeclared. That is a big error, and it's not our program fault. The compiler didn't catch it, but using print statements, we're able to find something is definitely wrong with our program. So this is where you would start using the second compiler. So I went to W3 Schools and put the same code in just by copying it, Control A, Control C. We just selected all our code and copied it. And next thing we're going to do is open Google. We're about to look for W3 Schools and type in C++. There it is, C++ tutorial. There's an online C++ compiler, so you can go to any of these examples where it says try it for yourself. Next, we're going to take the code that we just copied and pasted from DevC++, and we're going to paste it right here into this example on W3 Schools. And we're going to compile it using their system. So this is what it's supposed to be. When we have a value that's not declared, it should be 0, not 55. And y should be 0 because we set it to 0. So this is exactly what DevC++ was saying. So we're going to switch and start using Visual Studio in the future. So this is the Savage Scientist Ed, Governor of the State of Swampland, And I just want you to know, sometimes when something is cheap or free, you have to look to make sure it's able to do what it's supposed to. And this is the type of debugging you have to know how to do. And when everyone else is using DevC++ on the job, you tell them, hey, let's try this in another compiler, and find out that nothing is wrong with the code. It's just the compiler that they were using. Now you the hero in the building, and when it's time to get a raise, now you just hit 6 figures. So this is the end of day 17. So you might be wondering, why am I holding this book? Well, this is an old book from 2000, 1999, 2000, somewhere around there. That's basically the Bible for the standard template library. And this is by Nikolai M. Justicius. And I can't say this guy's name, but Nikolai M. Justus. I'll just say Justus. Let's put that over here. One more thing before we go further into this video. I have this website listed to cplusreference.com. There you'll be able to find more information on the data structures, iterators, all the other good stuff in the STL. The same stuff that you would have in this book, but an updated version. So click the link in the description for more information on STL data structures. So now it's time for us to talk about templates. And in STL, the T stands for templates. So now, what is a template? Well, a template is a parameterized type or a way of representing our type as a parameter. And in Java, this is known as generics. And since we're doing C++, we're going to use templates. It's all the same thing. In any other language, it's the same concept. So we're going to start off creating our template using the template keyword. And then we're going to have our angle brackets right here, angle brackets. And we're going to have the type name keyword, followed by a T. Now you can use a N, a V, or R, whatever we're going to use, but we have T here because that's the standard whenever we doing this in C++. So here's an example of actually using our template. So we are using of type T, we're going to have a variable called X. And at runtime, X is going to get the type of whatever is on the other side of our equals. So right here, we have
A quiz.
Pause the video, figure this out, and we're going to come back. So hopefully you had enough time to figure this out. So what is X referring to? Well, in this example, T is a constant character array. This is a constant character array. And we would normally write that as and Twitter has 1, 2, 3, 4, 5, 6, 7. So that is what X referred to. So we could have came back and modified this code, and instead of having the word Twitter here, we would have 78. So in this example, what is T referring to? This is an integer. So X is an integer. I know this might be a little complicated, but play with it a little while. We're going to get into more examples of using this later. So you're going to start seeing this notation
As we dig deeper into the STL.
So in the STL, we also have our string library. That is identical to creating a character array, but we have access to many functions like size. We could call the size function, and that's going to tell us how many elements are in this string. Let's say this string is called S1. So we would just say S1 size, and that's going to tell us 1, 2, 3, 4, 5, 6, 7, 8. That's going to return the value 8. That is what the size function does. So you can't do that in character array. So this is powerful stuff here with our string class. So now let's move on to vector. Vector is kind of like an array powered by Hellcat here. In comparison, a vector would make an array look like this. 797 horsepower. When you move from an array to a vector, you're going to have a lot of functionality. Like you could use some of the sorting algorithms on it. You could use push, pop from push in, push from the top, pop from the top. So it could act like a stack. You have, so you could still address elements in a vector the same way it would be done in an array. So we're going to talk about vectors later in this video. I want you to notice with our vector here. Our vector is called V1, and it's going to have some type. This type will be declared when we create our vector. So we're going to have more of that in this video, so stay tuned for it. So in this example, type could be int, bool, character, or even a class, some object. So vectors are powerful. That's all you need to know. And read that. If you want to know more, don't forget to check this out. A lot of information about vectors. Or click that link in the description below. So vectors, very powerful. So now let's talk about our map data structure. It creates a key value pair. And notice, we're using our templates again. It's gonna pair two types. So this could be int and character, or anything else. Int, character, and it's gonna create a key value pair. We're gonna talk about that in this video. So next, we're gonna talk about some of the STL algorithms. Very powerful stuff. Like our reverse algorithm. We're going to have our sorting algorithm that puts it in order. And we're going to have min and max. And in map, max and min is the same as ceiling and floor. So we're going to talk about that in this video. So it's time for us to start coding. So follow me along to DevC++. We're going to start off by creating a new project. And we're going to name this one Day 18. And it's going to be a console application. And select our Day 18 folder. Save everything in there. And we're going to put our user namespace std line right here. So first we're going to use strings. To use string, we must include our header file for string. Include string. That's it. Let's create our first string. String S1 equals capital Swampland is Arctic City. And let's print it. And there's the results. Capital Swampland is Arctic City. Beautiful results. So let's go in and modify our string. So how many characters are in this string? So let's see. our character count, meaning how many characters are in here. We're going to go to s1.size. So it's important to start paying attention to the documentation on the classes and the methods that we are using as we continue to explore the STL. So looking at this screenshot, std scope resolution are 2: string. That is saying our string S1 string. That is actually where it comes from. It's part of the standard namespace, and it's a string. It's the same thing as saying int or character. So the size method returns right here a constant expression size type. That's just meaning that we're going to return an integer value. And that's the name of it, size. And that's basically it. We are using the size method. When you look at the official documentation on the C++ language, it could get a little confusing, all this other crap. But if you look and use the book, it's a little easier. And the examples are probably the best way to look at this stuff. So that's why I have an example. So in my example, we're using the size method on our S1 string. So let's continue. And now let's recompile it. It is showing the size of this character string as 39. So this is something good. So here's another great one. So now we got our size here. Let's print our string in reverse order. So let's put our algorithms to work. Algorithm, include algorithm. And this gives us access to the reverse function. So we could come right here on line 10, reverse it. And the first argument in reverse would be the beginning position. So we could say s1.begin, begin. And our ending position would be s1.end. And this function will reverse the order of our string or whatever we have in our array. And here's the results. We can put our string on its own line too. Let's do that. So what I want to do is first I want to print our before and after on our string. So this is the before line. This is after. This is our assignment and declaration statement. And this is where we're going to print the string before we hit line 11. And this is the reversals on line 11 and on line 12. This is the results of our reversal. So this is what our string looked like after using our reversal algorithm. String reversals is a great way to test for palindromes or to piss people off in a live stream. So looking back here at line 11, we're using our STL reverse function. And once this function completes, we have just mutated our original object. In this case, it's S1. S1 changed and is not the same. So that's the reason why I wanted to show you on line 10, the before, and on line 12, after. The size remained the same. The contents of our string changed. So let's play with some vectors. First thing we're going to do, line 3, hit our include statement. Include vector. And it's still part of the standard template library, so this line 5, is still valid. We're going to remove all the code from our string experiment. So let's start here on line 10. We have our vector name. It's not a keyword, it's just the name vector, because Vector is a class within the standard template library. It's just the name of our container. And here is our template. We're going to use integer. And we're creating a vector of ints. And it's going to be named v1. And to find the size of v1, type in v1.size. And let's print that information. We want to find out how many elements are in our vector. So size of v1 equals an integer value. So we could go to line 11 and take our v1.size because that function returns an integer value. So we could put the results right into our cout statement. And let's make sure we include our brackets to make it so cout works because we want to print the size value of v1. And we have an empty vector. We could resize our vector on the spot also. v1.resize. We're going to set it to the size 90. 90 elements in this vector. And that's how we resize a vector. It is very difficult to resize an array in the same way. We would have to copy the array. We would have to copy each element to a new array. So that's one of the advantages about using vectors, the resizing capabilities. So let's add some items to our vector. So one way we could do it is right here in the constructor, or right here on line 10, when we create it, we could just put our numbers here, 2, 34, and 91. So if we want to print all the values in our vector, we would have to do it the same way we would do an array. Using the for statement. So for int I equals 0, the next part is going to be the while part of it. While I is less than our v1.size, we're going to increment I. And now for the printing part, we're going to just remove this line. We're going to copy this. We're going to copy and drop that on line 15. So even though we just copied this, we want to look at v1 at the position I. And we want to also print I. So v1 equals this, and we want to space after our value here at position equals I and in line. And here's the result of our vector. As you can see, only 3 elements are in a vector. At 0, we have our 2. So this is 0, 1, 2. And you see how those match up. At 2, we have our 91, 0, 1, 2. So to simplify our results, let's get rid of line 11 where we resized it to 90. So now that we got rid of that resize, our vector looks the way it's supposed to. So let's remove some items out of this vector. v1 dot push pop back, P-O-P underscore B-A-C-K. That's going to remove the 91. Now the 91 is gone. It stops at 34. So I know I said we wasn't going to talk about iterators, but in this example, we're going to put our 91 back into our vector v1 after calling the pop back on line 11. So there's a lot of ways we could have did this. Like we could have just said pushback 91, but that'll be using the same. So that'll be something that we already covered. So let's take a look at how to do it with iterators. So first I'm about to copy line 12 because I want to show the size of our vector again after adding our 91 again. So right here, we're going to just put a line in here, COUT, that just so we could know whenever we review our code where it is insertion happened. Insert, INSERT, 91 using iterator. So we're going to use the insert method. All right, so first thing we have to do is create our iterator. So iterator is part of the vector class. So to access that, we would have to call it via a vector. So we're going to go into our vector of int, because that's what v1 is. It's an int vector. And you can see it right here. We could also bring this in so it could look similar. And we're going to use our scope resolution operator to access iterator. And we're going to name this v1 iter. And that's all we have to do. And now that we have our vector iterator created, we want to set our vector iterator to the beginning of our v1. So let's do that on line 15. v1, capital ITER. So now let's call our v1 insert. And first we're going to put our v1 begin. And we want to add 2 to the beginning because we want this position. So we have 0 or we have 1, 2, 3. So we're going to put it at 2. And it's going to be the value 91. And that is directly using this method. Iterator position. This is our value 91 right here. Constant value of whatever type we had. So let's see what happened when we run it. So after our insertion, our size, after inserting, our size changed to 3, and our 91 is at position 2, 0, 1, 2. So we were able to use an iterator to insert a value into our vector. So we could have got rid of all this line 15 and 16 and insert it into our vector using the bracket notation. But first we have to resize the vector. And we're going to set our new size to 3. And now we could go into v1, 2, and set that to 91. And now our 91 is back inserted. And I also want to demonstrate sorting. So as you can see, this is out of order. We have 3, 122, 334, and 91. Let's sort in descending order. We're going to add more items to our vector. Let's see, v1 pushback. 1, the number 1, and we're going to do a couple more pushbacks. So we're going to do 21, 31, negative 198, and 12. And let's sort this thing now. So we're going to start off with STD, standard template library, method or algorithm called STD sort. S-O-R-T, that's our sort. And now we're going to start from V1 begin. That's going to return the beginning of our vector. And if we want to sort through some arbitrary values, we could have actually specified the numbers like from 7 to 300. So we would just use those constants if we want to sort within that range. So we're going from beginning to end of our vector. So we're going to go v1.end. That's going to return the end of our vector. And now let's print. And our vector has the size 8 now. And the lowest position is the negative 198. And then it's going into an ascending order starting with the 1. And it's going to stop at 334 because that's the largest member of our vector V1. So we discussed vector now. Now it's time to talk about maps. So to create a map, first we got to have our include statement. Include map. And the map is still part of the STD namespace, standard namespace, or the STL, how we look at it. And you really don't need string vector and algorithm. Well, we're going to probably use algorithm, but you really don't need string and vector at this point. But to keep track of the topics that we already covered, I'm going to just leave them in here. So let's get rid of line 8. And we're about to clear all the code that we already wrote. So put that bracket on its own line. And now let's create our plan of what we're going to do. We're going to create a map. A map is a key value pair. And we're going to create a class, the model inventory in the store. So let's create our class, the model the store. Class item. And we're going to give our item public access. And we could have used structure too. I mean, it probably would have been better to use a structure. So we already started. So let's use item here. So our item will have int. And this is going to be our availability. And we're going to have a character. Oh, we could have used string here too. But we already started with character array. So we're going to give this our description. DESC for description. And the last thing would be double price. So we have our item here. And now let's create our map. Start off with the map keyword. And now for our template part, it's going to be 2 parts in our template. The first part will be one class or one item type and the second item type. So the first one here is going to be, let's just say it's going to be an integer. And our second would be an item. And the name of our map would be store. All right, so let's create a few items for our store. So item 1 would be I1. And we could use, and to populate our item, we're going to use the bracket notation separated by commas like this. So the first thing, or the first comma separated item will be our availability. So let's say we're going to have 23 of these items, and the description would be, or really the name, LG D60. piece of crap. And the price would be 0.16 cents. So we have one item for our store. And let's go up to line 12 and change our character array to a constant character array, because this is a constant and we don't want any problems in our code in the future. So let's create some more items. I'm gonna just copy line 19 5 times. So in this store, no one is buying V60s, no matter how cheap it is. So let's increase our quantity to 233. I can't even give these things away. Let's hit line 20 with item I2. We can have 2 Bonnevilles in stock. And let's set the price to $988.16. I don't know where these prices coming from. So our next item, I3, we're going to put 23 of these in stock. And we're going to name this, this is going to be some C++ books. And we're going to set the price to $32.88. All right, so let's do item I4 here. We're going to name this junk food. And let's set our junk food to $9.01. Like the Memphis area code. And let's set our stock to 523 items. All right, the next one, we're going to name this hammer. And we're going to set the price to $1.12. And we're going to put 3 of these in our inventory. Let's change this I1 to I5. And let's move the item I6. We're going to put 1 of these in our inventory. And this is going to be 1 Hellcat. We're going to sell this for $2.16. You better act fast because it won't last. I just got word that LG stopped selling phones, so we are about to change the value of our V60 to negative $30.16. We are paying people to take this out of our inventory. So now we are about to insert our 6 items into our map object called store. So there are multiple ways to do this. So the first way we could do this is use the insert method. So we'll call insert from our store. Like that, store.insert. And we're gonna, since this is a method, we're gonna use method notation just like this. And we're gonna use curly braces. And the first one will be our key or our index. So we're going to start with index 0, and we're going to insert item I1. So we just inserted our first item. So we could also insert items into our map using the square bracket notation. So we're going to insert into item 1 just like that. And we're going to use our equal sign, and we're going to set it equal to I2. So that's it. And the reason why this is working, this and this, is because our map takes an integer and an item. So that's our integer, and this is our integer. If we would have changed this to character, we would be putting characters in our square brackets and in this first part of our insert function. So let's insert some more. Let's see, in 2 we're going to have I3. So on line 29, let's do store.insert. And we're going to do 3 here. And I4. Close everything up. Okay, that. So, insert. And we're going to put 4 here. I5. and store insert and this would be 5. I6. Let's close everything up. All right, now that we have all the items in our store, or we have our inventory, this is how we could count how many items we have in our store, or how many unique items we have in our store. So we would just say store dot size. So the size method returns an integer value, so we could feed that directly into our cout statement and print our value directly to the screen. And we will be counting unique items in our store. So we're going to name this unique items. So we have our unique item count here. And now it's time to print all the items in our store. We're going to print this stuff. We're going to print our availability, description, and price. So let's start our for statement. And while I is less than, we'll just say 100. Because these values could be anything. So we don't count in a linear fashion. So we're going to say I plus plus. And pay attention to this video because I'm going to show you exactly why I used 100 here. All right, so now it's time for us to print our values, cout statement. Cout. We're going to print I because that's like the index. And we're going to put some space in between it. And, well, we could do a tab here. Tab there. And we're about to print store I. Use our dot operator to access this part. We are about to access our item. So dot is going to give us access to item. So dot item, and our item is going to end up, and we're going to print our availability first. So we would just say availability right here. Don't laugh at my spelling. Put a tab right there. All right, so now let's move to the next item we're going to do here, store I dot price. And our tab here, and now store I description, DESC. Do we use DESC? DESC for description. And our inline statement is going to put this on its own line. And one more thing we could do is we could print out an index or make it look like a chart. I'm not trying to make a perfect chart here, so this probably won't line up straight. So let's create the index for our chart. This I in our chart is going to be our, let's just say, item number. And we're going to follow that by a tab. And we're going to have our availability and another tab. And we're going to have our price, and another tab, and description. And let's fix this. And let's go to line 35 and finish up our for statement with our I set to 0. And this is the while part. While I is less than 100, we're going to increment I. And I is basically making this line happen. So we're going to print the value I. And this is kind of like our key and our item. And everything in our item, like our availability, price, and description, comes from our item class. And here are the public members of our item class: our availability, which is an integer, and our description, that's a character array, and our price, that's value double. So I want you to pay attention to line 19 to 24. If you notice, we use curly braces to populate our items. So we could look at this method as a shorthand notation as to writing it like this, where we use the dot operator to access each of the member functions like the availability, description, and price to populate our items. So that explains why we use the curly braces on lines 19 through 24. Now, let's run our program. So this acts as our index or the header line in our chart. So let's highlight it. This corresponds with line 34, where we print our item number, our availability, our price, and our description. And you can see we have 233 LG V60s with a negative price. And everything lines up correctly. And we have our unique items 6. That means we have 6 different items. Let's set up a value to track how many items we have in our store. We're going to name this total items. And let's set it equal to 0. And when we get to this line, we're going to print our total item. And let's put a label here to just to say what our total items are. Set in, put our brackets there. And now, this is how we're going to increment our total items. So we are looking at this line. So we will add this line every time. So we will say, so on line 39, we are about to set our total items. And we're going to use our plus equals. And what they're saying is we're going to add to our total items the new value of store I plus availability. So we're going to copy this line and drop it right here. So this line is going to update our total items with the availability of the current item. So if we were visiting item 1, is going to update our total by 233, and the next one is going to update it by 2. So let's see that in action. So you notice our unique items is 6. So we have 6 different items in our store. But our total items didn't print. And that's because of this. We tried to access an item that doesn't exist with key value 6. So what I'm showing you here is if we access a value that doesn't exist in our map, we would lose the ability to traverse our map using key values. And the only way to get back to the beginning of our map would be to use an iterator. So to fix this, the only thing we have to do is hit line 36 and change this 100 to 6, meaning while I is less than 6, we're going to print the value. We're going to run through this count. And we'll be able to see our count now. And there go our count. We have 785 items in our store. And the reason why we didn't get this line last time is because we accessed an item that's not in our store, or that is not in the inventory in our map class. So technically, this is the end of the video, but I want to provide you with more important ways of dealing with our maps and our iterators. So I'm about to show you the erase function in our map. And remember, when we're using our erase, we are erasing based on our key value, which is an integer in this example. So all our keys can map to this 0 on the insert and this 1, 2, 3, 4, and 5. So let's remove an item. And we're going to put it after we initialize our items to 0 on this line 33. So let's erase an item. So from our map object, called store in this example, we're about to call the erase function. And erase just basically removes the item based on its key. So this is going to be our key. And so we're going to remove item 3. And now let's run our program. So here's our results. Once we deleted our object, we broke the link, so we couldn't access any more objects in our store. So I'm going to show you how iterators work and why it's better to use iterators to move through our list instead of playing around with our index values. And also, we could use characters, objects, anything for our key values. So I would not advise using objects as our key, but it's possible in C++. So iterators provide a more universal solution to this problem. So let's go and create the iterator. So let's start right here before our erase. And let's create our iterator. So we're going to start off with map. That is the container. And our current map has this signature, an integer and an item. So we're about to call the iterator from our map class that's going to create the same style of map. So we're going to hit int and item. And we're going to use our scope resolution operator to access iterator at the class level. And if you go through the documentation on map, you would see that iterator is a method or a member of our map class. We're going to give this iterator a name and call it iter. Iter. And we're going to set it to the beginning of our store object. So that means it's going to point to our first insert right here at position 0, line 26 with key value 0. So let's set it up. Store.begin. And that's how we create our beginning and use the iterator so we could print out all the items in our store or inventory, and we're going to compare the results. So with our iterator that's created on line 34, we're going to use a while loop this time. And we're going to say while iter is not equal to store.end, we're going to process some actions. And I want you to pay attention to iter. Iter is a copy of our map object. So right here, this is what iter is. It's one of these pair structures or tuples. It contains an integer value and an item. That's all iter is. And it's a pointer. So that means we can't use the dot operator when referring to the first and second argument in our iterator. We're going to have to use the arrow operator. So now let's print the contents of our map. Start off with cout, iter, first. So first means the first item or the first object in our map. Second is the second item. So we can look at this in this form. So int is first, item is second. And when we print item, you notice we're going to start using our dot operator, and it's going to act the same way as when we used it on the store object. So it's only the first and second that we're going to use our arrow operator. So when we call first, we are just returning an integer value. So iter first, pointing to that first object. So that's all we need, because we printing in the same order that we have in our for statement when we used our array-like notation. We printed the I value, so we are printing something like our I value right here. But we printed our index or key. So next, we're going to go into store. So next, we're going to put some space here in the tab. And the second thing we're about to print is iter second. And now we're about to access our item class. And this is the item class. So we want to access our availability, our description, and our price. And we want to do it in the same order we did it using the for loop, or whenever we didn't use an iterator. So we're going to call second dot, because now we actually referring to our item or our object. So we're going to call second dot availability. And we're going to put a tab here. And we're about to call iter second. And remember, when we say second, we are just talking about this item, first and second. I think I'm done repeating myself on that. I just want to make sure I'm not skipping it. So we're going to call second price. And let's move to another line. And we're going to call iter second description. And we're going to post this on its own line. All this is going to print on one line, similar to how it looks here. And we could have put this on another line too, so it could be shortened. And if we leave our while statement in this order, we will have an infinite loop and it will not work. So now we have to move our iterator with each loop. So to move our iterator is similar to how we move our I value to move to the next item. So to move the iterator, we just say iter plus plus. And to understand how all this works, I suggest going back into the documentation on iterators for our map class. And it will provide you with more than enough information. So this is what it looks like. And I'm missing a tab, so let's put a tab in here so we can get this to look exactly like that. So right here, we should have had another tab. And I also want to put a line here so we could see the difference. Not using iterator. Notice, when we used our iterator, we got our Hellcat and our Hummer. But when we used the array notation, that allowed us to point to the element at index 3, which was already previously removed. That blew up our program, so we couldn't access the remaining items in our map. But notice highlighted in this green, when we used our iterator, we were able to skip 3 and continue looping through the rest of our map. So that's the reason why I stressed iterators. And I'm sorry we had to go back to iterators for this video, but that is why this is so important. So this is the Savage Scientist Ed here with another video on C++. And this concludes day 18. Print out a certificate. You earned it. You reached day 19 in our C++ journey. As I congratulate you, stand by because this video is about to start.
This is the Savage Scientist Ed right here, and I'm writing code in a police car.
This is the end of video 1 in our journey to learn C++. And like I said, print yourself a certificate because you earned it. Now don't go and buy a WWF belt just yet. At the end of the next video, then you earn that belt. Let's talk about the resources we used for this course. C++ in 21 days is one great resource. Following this book will help you. And the second resource, the STL, Standard Template Library by this guy, Nikolai. Last name starts with a J. So I'm going to put links in the description to both of these books and also other resources that we use to learn C++, because just because you finish this course, that doesn't mean the learning is over. So some of the things we covered in this course, starting on day 1, we had our introduction to programming and setting up DevC++, and we also set up VS Code. We talked about compiling and a lot of the necessary stuff that you would have to understand before starting a program, like what is a compiler, what is a programming language, all that stuff. So then on day 2, we created our first program, a Hello World sample program. It was very basic, but it was to get your feet wet in learning C++. So on day 3, we looked at some of the C++ keywords, the syntax, and we went into what the compiler's job is. So on day 4, we got user input, and we looked at the IOStream functions. Day 5, we looked at data types, variables, and C++ naming conventions. That was a great video if you want to get into understanding camel case, arrow case, and all that other stuff. So that was day 5. Day 6, we went into some of the math and arithmetic operations. And on day 7, we looked at Boolean logic. I'm putting a real square around this one because this is what makes computer science logic. So if you have any trouble with understanding how if loops and how the loops work, then make sure you go back to this video. And we recapped everything from day 1 all the way to day 7 on day 8. That was our recap. So at the end of day 7, we left off with Boolean/logical operators. Then we went straight into loops and conditional statements. This is another important topic that makes it so when you understand this, then you're a real programmer. So then we moved into C++ functions. Very, very important part of the C++ language. If it wouldn't be for functions, you wouldn't really have a program. So we talked a lot about functions, and really everything going to the end of these videos were about functions in some way, fashion, or form. And after we covered functions, we started talking about C++ pointers and references. That's one of the things that makes C++ such a powerful language, and the C programming language, is the fact that you could refer to the memory location of your data using pointers and references. And to also continue with our topic on pointers, we talked about function pointers. Another important feature of the C++ language is basically creating a generic function that you could plug in the function at runtime or whenever it's necessary in our programs. If you go into game design, game development, function pointers are used a lot. After we covered function pointers, we started talking about structures. So structs in C gave rise to classes. So on C++ object-oriented programming, day one, we covered classes. This is extremely important, all three of these videos, because we covered classes here and we started to use constructors here. So on our third object-oriented programming day, we separated the implementation file from the interface. And that's basically how APIs work. And then on day 17, we covered exception handling and debugging. Don't mind this badly drawn circle because it's not important. We covered exception handling and debugging on day 17. And then the long one, the video you just watched, which should be about 2 or 3 days in its own, was this. C++ STL. And you notice it's STL1. We're going to talk more about the STL in part 2 of this course. So STL is a very important part of the C++ programming language. That's the standard template library. We went over what templates are, and we played with vectors, strings, and more to come. So really, the final exam for this course would actually be being honest with yourself. Do you really have a decent understanding of these topics? Because if you don't, then go back, review them, do a few programming examples, and have fun learning this stuff. Programming is supposed to be fun. If you don't like programming, then stop watching these videos and go find something else to watch. But if you're serious and you think this is fun, then continue on to video 2.